The HPCL exam 22 is announced. The date is yet to be announced, but date can be announced anytime, maybe sooner as well, like ATC gave the surprise. So always be prepared for this examination. And today, the entire electrical and electronics team, we thought that let's have the paper discussion. Let's have the previous year. So guys, in this paper, in this particular session, whatever were the questions asked in electrical technical portion in the 2021, we are going to discuss them so that you get an idea how the paper is. And we have done the analysis and we have got that very simple. And ये तो हमने आपको पहले भी बोला है, like the pattern of the paper also, if you see, it is containing total 170 questions. Right, out of which 85 are technical, 85 are aptitude. Aptitude ke liye I will take separate session, but aptitude is also very, very easy, right? But this 170 questions, the time is 150 minutes, 2.5 hours. So you can automatically imagine, how the level is going to be. Over to you, Ashutosh Sir.
Thank you so much, sir. So how are you guys? Just comment, are you able to follow us and are you ready for this session? Because this session, see, as sir was saying, giving the pattern of the question paper, you see there are 170 questions that you have to attempt in 150 minutes. But please understand the level of questions that are being asked. We have seen the question paper that we are going to discuss, and believe us, you can easily solve this question paper. I think 10-20 minutes are going to be remaining as a buffer only, because the technical paper is going to be extremely straightforward. If you have read the concept, if you have attended the sessions, it is going to be quite easy for you to do it within the time. And I think, sir, aptitude is going to take little more time.
As compared to technical. Because aptitude, at least you need to, some questions will be straight, but some questions you need to solve.
Yes.
But here, sir, I don't think anything to solve.
Straightforward questions we have seen. If you have just even sit in the class, don't even write anything, I think you will be able to do this.
So guys, here, that's right, sir. Here we are there to describe the students. So maybe this 85 question session may go on up to 1.5 or 2 hours. But actually, sir, if I have to just discuss 85 questions, if I have to solve 85 questions, I think not even 1 hour is required.
Yes,
like
definitely.
that. Okay, not even 1 hour is going to be required if you are very clear with the concepts, right? So that means remaining 1 hour you can approach aptitude, 1 hour technical, and remaining 30 minutes can be total revision. You can just review what you have done, what you have not done. But I get the feeling, Ashutosh Sir, that students लगता है बहुत prepared है HPCL के. Yeah, they also know that level is very easy, and they don't have that enthusiasm in looking into that previous year paper discussion.
See, what you are going to get in these sessions, and let me just clear in the minds of the students. See, you are not going to get, we are not saying that questions are going to be repeating or anything else like that. The only thing we are going to deliver here in this session is we are going to boost your confidence that for this examination, at least when you are going for the examination, be 100% confident that sir इसको तो फोड़ के ही आना है.
So yes, definitely.
और सर अगर ये question मैं बता रहा हूँ, all of you, if you are not able to crack this examination, this level of question paper, so believe that you are not preparing at all.
So this can be beneficial in two different ways. So we have Sanjay sir also live with us. Very good morning, Sanjay sir. Right.
Hello, sir.
So we have guys two different analysis. One, if you are able to solve all these questions today, and you get a booster, that 22 HPCL also is going to be very simple for you. Number 1 point. And as Ashutosh sir correctly said, that if you are not able to solve these category question, better don't prepare anything, because this is the easiest.
No, start preparing.
Then you start not preparing. You're not prepared. This is the easiest that you can expect.
Easiest
actually.
You can expect.
Easiest. Okay. So I think, sir, students may keep joining slowly. ऐसा लग तो रहा है कि students are not much enthusiastic about it. Guys, how's the Josh? But I don't see that Josh. So let's get started with the questions, I think.
I think students are going to be joining us soon. And after Rakesh Sir, I will be, sir, you will be dealing with which subjects?
I'll be dealing, guys, I'll be taking up this questions from signals, electromagnetic theory and digital electronics along with microprocessor. After that, Ashutosh Sir will come again. He's here only. So he'll just join once again to discuss up your core areas of machines, power systems, power electronics. And then, Sanjay Sir will be there for network and analog discussions. Phanindra Sir is there for measurements and control system discussions. So all the particular subjects are going to be discussed, right? And as I told you, aptitude I can discuss in another session where I will take up even other branch questions so that you could get a good idea of the aptitude practice as well.
Yes. So guys, just quickly share the session with your friends and colleagues so that more and more people are going to be joining with us and make this session a really big successful event, not for us, just for you only, because is Saturday, Sunday we are working beyond our, you can say, beyond our schedule, just to give you the morale boost up and confidence for this examination. And this session is really going to be very interesting because we have multiple faculties, the India's best faculties we are having on board, and you will be interacting with the faculties. You can ask any of your doubts related to the examination and related to the technical subjects that we are dealing. So all the best, guys. Okay, so all the best, guys. Just now enjoy the phenomena called Rakesh Sir, and then I'm going to join soon.
Yeah, sure.
Okay, sir. Over to you, sir.
Okay, thank you so much, sir. Guys, so let's get started with the questions immediately. This is in case somebody new to my session. This is a brief intro about me. This is your mentor and educator, Rakesh. I have secured All India rank 9th in GATE, completed my masters from Indian Institute of Science, and these are my major area of expertise, as you are able to see here. Right, just one quick update for you. As always, you know, the BYJU'S Exam Prep, okay, brings you yet another free, mega, very important, crucial workshop, and this time by once again your favorite Abhinav Negi sir, IIT Delhi alumni, having more than 10-11 years of experience, and he's going to give you the step-by-step guidance from beginner to GATE topper. And he's going to come live tonight itself, that is 30th of July, 8 p.m. Yes, this time the workshop is on Saturday, 8 p.m. tonight only, and this is going to be on the BYJU'S Exam Prep app. This is not a YouTube event, this is on the app. So register for the free workshop. Just log into the BYJU'S Exam Prep app, register, and get the step-by-step guidance from beginner to eventually a GATE. Everyone is a beginner and everybody dreams to be a GATE topper, but not only dreaming will work. What are the steps to be taken? Okay, Abhinav sir is going to speak about that. Okay, also one more reminder, guide, the next Sunday Fun Day. The next Sunday Fun Day is live in front of you. Yes, so we have the next Sunday Fun Day where we are going to talk about ratio, averages, allegations. Okay, and this is Sunday. So those who have been following our YouTube channel, we have been dealing, you know, on almost every Sunday. Let's try to make the Sunday as fun day, and tomorrow is the next Sunday to make it as a fun day, practicing aptitude, ratio, averages, allegation with the ratio, problem of averages. So several important category of questions covered up here. Questions based on mixtures, question of weighted average, ratio, ages problem, all those things covered up tomorrow. That is Sunday at 11 a.m. Join me live on the same channel. If you are not subscribed, subscribe. And also, guys, this particular aptitude sessions is generic, means it is going to help you. That is why we don't mention any exam here. Okay, this will help you for GATE, for HPCL, for engineering services, prelims, everywhere this is going to help you, okay? Everywhere this is going to help you. The Sunday at 11 a.m. Okay, and guys, very soon, the coming week, to take out your fear of probability. You know, usually students fear with probability, right? 51 most expected questions of probability. Right, I am going to take it up, you know, dividing into 3 to 4 sessions. It is going to start on the coming week, that is somewhere around Tuesday, Wednesday. So just stay updated to our channel. Dates we will confirm you today, but somewhere around Tuesday, Wednesday, we are going to start this as a regular basis to cover up 51 most expected questions of probability. Stay subscribed, and now these 51 questions will be those questions that can make you the beginner to the pro in probability. So now become master in probability. Okay, get out your fear. Right now, guys, let's get started. Let's come to the point, and this is signal and system. This is signals and systems. The first thing, all 85 questions we are going to discuss of the previous year questions. So number 1, which of the following operation is not discrete time? Which of the following operation of the discrete time is not memoryless? Guys, very simple question. It is not memoryless. See, option number A. See, what is the option number A? Signal multiplier. Okay, it is a type of system which takes 2 signals and multiply them. Okay, it is x1n, x2n. If I want to write down the option number B, constant multiplier. So you feed any input xn, the output is some constant multiplication with the input kxn. Right. Option number C, adder. You feed any 2 inputs. It may be more than 2 also, but let's take 2 example as a case. Okay, it adds the 2 different inputs, x1n and x2n. Option number D, unit delay. Unit delay is represented by right shift, guys. So what should be the answer here? What should be the answer here? Since signal is a little bit mathematical type of subject, so there, you know, you can say there are little bit questions where you need to think and solve. Rest all is very easy in HPCL. Okay, is not memoryless. So yeah, does it involve any memory? No, this is memoryless because what is a memoryless system? What is a memoryless system? Which does not require memory. Does not require memory means there should not be any past values. So it only depends on present. It is memoryless. again, yn depends on xn, n and n. So that means this is also memoryless. This is also known as the memoryless. x1n plus x2n memoryless. But here you require the past values. Okay. Suppose you want to calculate y of 2. Suppose somebody wants to calculate y of 2. So that will be equal to x of 1. The value of the input at time equal to 1. That means here the output depends on the past values. And hence this is a system which is having memory, which requires memory. So it is not memoryless. It is not memoryless, right? So option number D is the correct option. Option number D is the one which is not a memoryless system. Rest all are memoryless system. Okay. Chalo, going ahead to the second question. Now see what easier they can ask from this. Okay, a continuous time signal is said to be periodic if xt is equal to xt plus t naught. What is the value of t naught? Sir, t naught is known as the fundamental period. Usually gate will give you what? Gate will give you 2 or 3 addition of 2-3 different periodic signals. Find that whether the resultant is periodic. Find the final time period. But what they are asking? What is the T naught? Everybody knows that T naught is the period, or simply known as the fundamental time period. Right? Option number A. Which of the following is an example of static system? Now once again guys, what is the static system? Where the output depending. Okay. Okay. Yahan pe tha memoryless. It's nearly the same. Memoryless. Memoryless. Okay, no past samples should be there in the memoryless. Similarly, normally we define a static system as one, right, in which the output depends only on present values. Only on the present values. So one and the same thing. Now, is this a static system? So see here, option number A, I will show you one calculation. Sir, what should be the y3? Y3 will be equal to x of 9, and this goes to the future. You are calculating output at 3 and the input required is at 9, right? Then this will take you towards past. This is clearly past. N minus 2. Right, this is x minus n. Chalo, D ka example bhi main deta hu. Suppose somebody wants to calculate the output at -1, so it becomes x of +1. Right, x of +1. You are computing at -1, so 1 kahan pe aayega? 1 is at future. Okay, 2 units time ahead. So this also requires future. This also requiring the future. So only option which requires only present value is xn and x square. Maybe the input is squared, but what is the value of the input required? So the value of the input required is the value at time n only. So option number C, guys. Option number, no, Sai Krishna, it's option number C. It's option number C. Okay. Next question on your screen. Amplitude of anti-symmetric signal. Anti-symmetric signal also known as odd symmetric signal. Conjugate symmetric nahi, simple anti-symmetric. Okay. So anti-symmetric signal is odd symmetric signal in which x of minus t is minus of xt, and odd symmetric signal is always 0 at the origin. Is always 0 at the origin. You can also feel like this. X of minus 0 is minus of x0. Right? That means x of minus 0 is x0 only. Okay, so bring both the x0s on left. 2x0 equal to 0. x0 is 0. Any odd symmetric signal should be 0 at the origin. So the correct answer is option number D. It is always 0 at the origin. It is always 0 at the origin. Option number D being the correct option. Okay. Next one. Find the Z transform of half power n u minus n. Half power n u minus n, right? You can use the property and compute this one. Okay, so if I take 2 power n u n, okay, let me give you the quick revision of the formula as well. Okay, for a power n u n, see in the signals commonly we remember for Z transform two important formula: a power n u n and a power n u minus n minus 1. U minus n minus 1. So you can convert u minus n minus 1 to u minus n by the time shift property, or you can start with a power n u n. Sir, what is the Z transform for a power n u n? It is given by 1 upon 1 minus a z inverse, or that is z upon z minus a. Here the options are in positive power of z. So that is z upon z minus a, or 1 upon 1 minus a z inverse. Both are correct with the ROC. The question is not asking ROC, but let me tell you, ROC is mod z greater than mod a. Exterior circle lying outside the pole, like outside the outermost pole. Okay. So similarly, here I need u minus n and half power n. 1 by 2 is 2 inverse. So let me write it as 2 power n u minus n. And if this is 2 power n u minus n, so what I will do is, I will start with the 2 power n u n and then apply the time reversal property. 2 power n un. So that should have the z transform, z upon z minus 2. So what should be the z transform for 2 power n u minus n? Guys, a property. If yn is having the z transform yz, what is the z transform for y minus n? Time reversal property. What should be the z transform for y minus n? It is given by y 1 by z. Take the reciprocal of z. तो यहाँ पे हो गया 1 upon z divided by 1 upon z minus 2. यहाँ 1 upon 1 minus 2z. 1 upon 1 minus 2z. That's it. Completed. 1 upon 1 minus 2z. Okay. So the correct answer for you is option number D. The correct answer is option number D. All okay? All good? Question number 6. See how simply we are going. Okay. Which of the following is not a deterministic signal? Okay, noise is a random signal. The value cannot be determined. It's a random phenomena. Noise cannot be deterministic. Rest, exponential, sine, cosine. You are able to define them as functions. So they are deterministic. Right, e power minus at, sine of omega t, cos of omega t. Deterministic signal is one whose value can be determined at every value of time, right? And because you have a mathematical relation, exponential wave, suppose e power minus at, sine of omega t, right? Because you know the relations, so that means given any value of time, you can compute the value of the signal. That is why they are the deterministic. Very simple question it was. Next, which of the following system is linear? Classification of system pe you are expecting many questions. Okay, memoryless, static, linear, time invariance pe bhi aa sakta hai. So which of the following system is linear, guys? Right, which of the following system is linear? So now for linearity, there is a very simple way of looking according to me. Right, if I start telling you option number B, yn is equal to modulus of xn. So always remember, when you want to test linearity, there is a full-fledged rule. Superposition check karna hai. Superposition has additivity and scaling. Let's make it simple, right? If a system with option number B is linear, option number B is modulus of xn. So try modulus of a plus b. Just additivity se try karenge. Do you know mod a plus b is mod a plus mod b? If there is any such identity, then the system can be linear. But mod of a plus b is actually less than equal to. It is not equal to mod of a plus b. Correct identity is less than equal to. There is an inequality. Okay. So b is non-linear. B is non-linear. C, cosine of xn. So cos of a plus b. Do you know any such identity that cos of a plus b is cos a plus cos b? Can you split? Can you split both the outputs? Output is cos xn. Let's take two input, a and b. Cos a plus b. Can you split at cos a plus cos b? No, na? The cos a plus b is cos a cos b minus sin a sin b. This is not correct. Option number D pe aa jate hain. Then you have output as exponential of the input. Let's take the input as e plus b. Right? Can it be written as e power a plus e power b? E power a plus b is actually e power a into e power b. Right? So this is also not true. So D cannot be linear. D cannot be linear. The only correct answer here is option number A. Yn is equal to xn plus nxn plus 1, because when you separately take yn equal to xn, dekho, whenever you take yn is equal to kxn, such a class of system, right, is always linear. Even if you add any DC term, any initial term, kxn plus some constant c, let me call it as mxn. Even if you add some constant c, this becomes non-linear, right? So linear relation means the output should be a function of input as x power 1. There is no other function acceptable like modulus, cosine, exponential, sine. All this will become non-linear, right? If I give you y is equal to x square n, that is also non-linear. That is a quadratic function. That is a quadratic function. Once again, you can say like that. Once again, you can say like that. Is the a plus b whole square equal to a square plus b square? It is a square plus b square plus an additional term 2ab. So this is not equal to a square plus b square. Correct. So hence that is non-linear. Only class linear that can be yn is equal to m into xn. Yn is equal to m into xn, because it follows additivity and scaling. अगर हम इसकी बात करें, if I test additivity, let me show you. Okay, suppose the input x1n has the output y1n given by mx1n, right? For the input x2n, the output is y2n, and that is given by mx2n. That is given by mx2n. So when the inputs is x1 plus x2, what will be the output? Output will be m into input. Output is simply m times input. M into x1n plus x2n. When you split the bracket mx1 plus mx2, that is equal to y1 plus y2. That is what additivity is. Okay. Second property dekhte hai, scaling. Linearity is one, linear system is one, which follows superposition, and superposition has two parts, additivity and scaling. Scaling is also known as the homogeneity, right? Scaling says that if an input is multiplied by some constant a, right? Suppose, let me take the value of that constant. Suppose input is 2xn. Corresponding to 2xn, what is the output? Corresponding to 2xn, the output is m into input, m into 2xn. That becomes 2mxn. That is 2yn. So if input is taken as 2xn, output is equal to 2yn. If the input is taken as 2xn, output is equal to the 2yn. Right? So that is why yn is equal to mxn is a linear system. Going ahead to the next question. Exponential signal, already just almost discussed, na? Exponential signal is an example of definitely deterministic, right? And is it periodic? E power minus at. Is it periodic? It is aperiodic. Periodicity is 1, where the value of the signal repeats. So it is deterministic and aperiodic signal. So these are again factual. This is again a factual question. Deterministic and aperiodic. Deterministic and aperiodic. Which of the following is not a valid advantage of digital filter over analog filter? Again a factual question. When you study the digital filter and analog filters you study in analog and network at both the places at the relevant application. So which of them is not a valid advantage of digital filter? No, it does not offer a higher bandwidth as compared to analog. This is not a valid advantage, higher bandwidth. Okay. Higher bandwidth. This is again a factual question where you compare analog filter and digital filter. Let's go to electromagnetics question. Right, extremely simple. Extremely simple. The dash states that, which theorem states that the line integral of magnetic field, around a closed path is exactly equal to the direct current enclosed by that path. It is the Ampere's circuital law. Option number A. It is the Ampere's law basically. Factual question, okay? Factual question it is. Correct, Tejasvi. It is the factual question. Okay. Which of the following is not an example of vector quantity? Electric and magnetic field intensities are both vector quantities, right? We studied that in the EMT. It's not even a EMT question. It's a basic physics question, you can say. Acceleration is a vector quantity. Acceleration is rate of change of velocity. Velocity is rate of change of displacement. Displacement, velocity, acceleration, all are vector quantity. Only mass is the one which is a scalar quantity. Correct, Tejasvi. The option number A is the very correct option. Okay. Moving ahead to the next. With the help of dash, the surface integral can be converted to volume integral. The surface integral over a closed surface f dot ds is equal to integral divergence f dv. Integral divergence f dv, and that is the Gauss divergence theorem. Divergence theorem is simply known as the Gauss divergence theorem. Okay, Gauss divergence theorem. So just very simple. EMT, like in gate it is okay, good level, but in the HPCL it is the simplest, you can say. In a hollow tube, if the velocity of air is constant everywhere inside the tube, then the divergence of the velocity field is. Velocity of air is constant. Okay. You can assume any example. It's a very simple question. Answer is 0. Because if a parameter is constant, divergence of that will be 0. See guys, what is the velocity? Right, even if you want to take 3 different components, but it is constant, right? So maybe kx ax, ky ay, kz az, right? What is del dot v? Divergence formula is given by del x of the x component, del y of the y component, del z of the z component. But it is very logical only. I told you, velocity is constant everywhere. Every coordinate it will be constant. Every direction it will have a constant component. Divergence 0 yoga, because differentiation of all the constants is 0. Right? So this kx, ky, kz, all of them should be constant, because the entire velocity they need to say it is constant. So answer is 0. Next, with reference to divergence theorem, which of the following statement is wrong? Which of the following statement is wrong? Okay, divergence of a scalar has no meaning. This is correct. This is true, because divergence is dot product of the del operator with the vector. F should be a vector, and this is known as the del operator. Okay, so divergence of a scalar, no, divergence can be calculated only for vector. Expression for divergence is different in different coordinates are different. Very correct. Expression in Cartesian coordinates, cylindrical coordinates, spherical coordinates, all of them have the different expression. Divergence of a vector is a vector quantity. No, it is a dot product. It is a dot product, so resultant should be scalar quantity. Though this is false, and they're asking false one only. Which of them is wrong? Option number C is wrong. Only one option can be correct, but yeah, still let's read the next option for clarity. Divergence operation can be represented by del. Yeah, that is what it is, evaluated and represented by the del operator only, del dot F. Okay, so which of the information is wrong? Which of the information is false? It is the option number C. Divergence of a vector will be a resultant scalar quantity. Okay, next one. Digital plus microprocessor questions. Convert B68 in the hexadecimal, convert this to the octal. Convert this to the octal. Right. Okay. Sure, Tejasvi. Okay. Convert B68 into equivalent octal system. Into the equivalent octal system. So what is the simplest thing you can do here? Okay. What is the simplest thing you can do here, guys? Converting hexa into octal. Okay, chalo, I have just made a call to Ashutosh Sir, that is why I was stuck. Okay, now what is the B? 1011, 60110, 81000. Okay, now I have opened every hexadecimal digit into 4-bit binary representation, and now what I am going to do is, to convert into octal, make the groups of 3. Okay, to convert any binary into octal, group the binary number into groups of 3, starting with the LSB. Start making groups of 3 and write down the octal conversion for every group. The 000 is 0, 1015, again 1015, again 1015. Correct answer, option number D, 5550. A number system simple question. A number system simple question it is, okay. Correct, gypsum. If the following Boolean expression is reduced, what will be the reduced result? Very simple. If the following Boolean expression is reduced, what is going to be the reduced result? So see guys, just use an identity. X plus YZ can be written as distributive theorem X plus Y, X plus Z. X plus Y, X plus Z. X plus Y, X plus Z. That is what is known as the distributive theorem. Every theorem in Boolean has two particular laws, right? This X plus Y, Z, चलो मैं दोनों लिख देता हूँ आपके लिए. Right, there are the two versions of distributive theorem. One is the regular that you even use in the mathematics. X into Y plus Z is X into Y. Open the bracket. Open the bracket. But what is the dual version of this? X plus dot converted to plus Y plus Z will be written as YZ is equal to X plus Y. Every dot is converted to plus. Every plus is converted to the dot. Correct? That is the dual of this. That is the dual of this. Okay, guys. So let us use this distributive theorem to complete this. So this is B plus BC, B plus B bar C, B plus BD. Right. Now, if this is on two theorems, I can use any other three variables also. W plus XYZ should be how much? W plus XYZ should be W plus X, W plus Y, W plus Z, right? And that is equal to, so here it should be equal to B plus BC, B plus B bar C, B plus BD. B is common. So B plus BC into B bar C into D. But B into B bar C, B into B bar is eventually 0. So answer is simply B plus 0. That is B, option number A. Simplest of the Boolean theorem question you can say. Okay. Next one, guys, is question from microprocessor, question number 17. In 8085 microprocessor, when the push instruction is executed, suppose push H I write. See, push instruction is for register pair always. Right? Gypsum you can do by K-map, but that is actually time consuming. See how simple theorem it is. Eventually you can do by K-map. I don't deny that, but this is a simple Boolean theorem. So Boolean theorems must be straight there into the brain. With a little bit practice, it will be there. Push instruction, when it is executed, the stack pointer is dash, and when pop is executed, the stack pointer is dash. They are asking just the nature of stack pointer. What happens to the value of stack pointer? The push H. H means register pair HL. H here represents the register pair HL, right? So whenever, guys, a quick review, whenever the push instruction is executed, okay, whenever the push instruction is executed, see the cycle of this. Suppose this is the top of stack, right? Right now, this is the top of stack. We call it as TOS. Okay, there is some content stored in this top location of stored. When the push instruction H is executed, what happens? The higher order, सबसे पहले क्या cycle होता है? Stack pointer is decremented by 1, and then the contents of higher order register H is stored into the memory location pointed by stack pointer. The contents of the stack pointer are again decremented by 1, and then the contents of lower order register. Contents of lower order register are stored into the memory location pointed by stack pointer. Right, this is how in 2 cycles the push H is executed, first higher order, then lower order. But eventually, what is the stack pointer? Stack pointer is eventually decremented by 2. And similarly, pop works reverse. The stack pointer is going to be incremented by 2. Whenever you are going to give the command, pop H, it's going to be exactly reverse. What happens? The contents of the memory location pointed by stack pointer, the contents of the memory location pointed by stack pointer is copied into the lower order. HL ka lower order is L, and then the stack pointer is incremented by 1. Then the contents of the next memory location pointed by stack pointer is copied into the higher order register, and stack pointer is again incremented by 1. So net it is incremented by 2. That is how a push and pop cycle works. Push and pop are even now the gate from gate 8085 has been removed recently from the past 2 years, right? But push and pop were earlier a very integral question part of the gate examination as well, and they keep asking in ESE as well, right? So these are my 17 questions. You have felt that it's just 11:34, somewhere around 11:02 or 11:03 we started, right? Then I think 5-10 minutes me and Ashutosh Sir had some interaction with you. So I think I have taken total 20-25 minutes describing you 17 questions. So see, if you are knowing all the questions and if you are just solving, the 17 questions would not take even 8 to 10 minutes. Yeah, even less, right? I was describing, I'm writing. That is why it takes a little bit of the time. Now Ashutosh Sir is ready, right? So once again, guys, before I leave, I'll give you my updates that tomorrow, Sunday, right, episode number 6 of the Sunday Fun Day, right, as you all were loving it. So this Sunday, again, 11 a.m. guys, tomorrow 11 a.m. I'm coming live, and this Sunday Fun Day covers some good amount of questions of basic topics of aptitude, so that you get edge in gate, ESE, even HPCL, everywhere you get the edge. And very soon I'm going to start one more session, one more series for you, 51 most expected questions of probability. Somewhere around Tuesday, Wednesday, I will notify you on the YouTube channel, also on the Telegram. Stay connected with me, right? And yes, let me now call upon Ashutosh Sir here live with you, right, guys? So tonight, once again, at 8 p.m. 30th July, mark the date. That is today only. Save the date for today. Log into the BYJU'S Exam Prep app. It's not on YouTube, and register for this free workshop, right? Everybody begins at some point of time, but eventually you dream to be a topper. But don't only dream. Take the step-by-step methods. And what is that step-by-step methods every beginner has to do? Take to be, becoming a gate topper. Your favorite Abhinav Negi sir, IIT Delhi alumni, more than 10-11 years of experience, the Civil Dawn, right, is going to take a live free workshop tonight at 8 p.m. Register on BYJU'S Exam Prep app. Ashutosh Sir, welcome back to the session.
Thank you so much, sir.
Students are now, I think, ready for the dhamakedar electrical machine power core. देखो core में कितना score करते हो? That is going to matter.
Sir, I think technical is quite easy.
Yes.
As far as HPCL is concerned, and you will see when sir is going to take aptitude part in some other session, that aptitude is going to be little more time taking for you
as compared to technical.
So you have to be gear up really for the aptitude part.
Correct.
Because if you have done,
and that is a game changer, sir. 50% is totally aptitude.
50% is aptitude, and if you are just gearing up your aptitude partner, you can well complete the paper within the stipulated time. So
right.
Technical, I think you don't need to worry. Whatever preparation you could have done, you have already done. Don't worry about this. Just keep on boosting your morale and confidence. That is very important, because time is going to be very important factor in HPCL.
That is why, see guys, actually the level of questions is, if it was not a time-based examination, time-bound examination, I would say no, don't even revise and go. You can directly go and attempt the question. But if you revise and go, the things will be fresh in the memory. Only one suggestion from my side: whenever you're going to appear in HPCL examination, whenever the dates are released, just revise your GATE notes. No need to even practice, I think. Right? Just even if you revise your GATE notes, it is done. Technical वहीं से हो जाएगा. Little bit practice of aptitude you do and appear in the examination. Over to you guys, and a big welcome to Ashutosh Sir once again. And guys, likes for Ashutosh Sir now live into the session. Thank you, sir.
Thank you so much, sir. Sir, I was watching your session. It was a wonderful session. But one thing, guys, you have to increase the number of live counts. That is very important, because we are coming up with these kind of sessions only for your interest, only for your career. So you have to do a little bit of contribution from your side. Share the session with your friends and colleagues right now, and let us increase the number of counts. Yes, everybody, just quickly hit the like button. And all the candidates who are live with me, Sanjay sir, good morning, and all these Dasi, Mr. Sai Krishna, Poli, and Mr. Gypsum. Interesting name, I think. Are you from outside India? So we'll be starting first with the electrical machines. I will be handling basically two core subjects, that is electrical machines and power system, but I will also be giving you the answers or keys for power electronics, and these are very straightforward questions. I think you are able to do that. Okay, no problem with that. So are you ready for machines now? Yes. See, these questions are going to be just you see na, just one statement. Don't even you need to write anything. You just read the question then and there, and you will be able to solve it. Anyways, let us start. Now see, you have you eaten halwa? You know what is halwa? You don't even need to chew it. Just put it in your mouth and automatically it is going inside. That is, so halwa type questions. See, halwa type questions. DC motor, the difference between armature torque and shaft torque is called. Now see, in these type of examinations, they are using these kind of words, jargon words, which you may not have seen in your standard books. For example, what is armature torque? Yes, generally we are talking about electromagnetic torque, interaction torque, load torque, shaft torque. What is this armature torque? So basically you have to be little bit flexible, and you have to be little bit, you can say, adaptive to the language that they are using in the examination. Armature torque is nothing but the developed torque. The developed torque. Now obviously the developed torque is not going to be completely available for the shaft. The shaft torque is that torque which you can use for supplying the load. And the difference between the developed torque and shaft torque is going to be what? The torque which you are not able to utilize because of the mechanical or the rotational losses. So that torque we are calling as lost torque. Lost torque. Okay. So guys, why it is so? Because of the iron and friction losses. Because of the iron and friction losses. Is it clear, everybody? So B is going to be the correct option. Now he is saying there is a 200 kVA single phase transformer with a voltage ratio of 6600660 volts has the following winding resistances R1 and R2. Find the resistance referred to the high voltage winding. Find the resistance referred to the high voltage winding. So let us see what is the situation. The situation is something like this. Suppose it is a two winding transformer like this. Suppose this is your 6600 volts high voltage side, and this is the low voltage side, 660 volts. Okay, R1 here is mentioned and R2 here is mentioned, and he is asking find the resistance referred to the high voltage side. It means this low voltage circuit you have to refer to the high voltage side. So how you are going to do this? Just see here. I am writing the equivalent resistance referred to the high voltage side. So you are referring the secondary side to the primary side, or low voltage side to the high voltage side. It means high voltage side resistance is not changing. So this is going to be simply R1. Now what you are referring? You are referring the low voltage side. So low voltage side resistance you have to normalize. How you are going to normalize? This is R2. Divide it number of turns from that side. Number of turns are going to be how much? Number of turns are going to be in accordance with the voltage ratio. So this is 6600 and this is 660. So low voltage side it is 660. And now you have to write the high voltage side turns ratio to where you are going. Where you are going? High voltage side 6600. 6600 and square it. What is R1 given? 1.75 plus R2 is 0.015 and this is going to be what? I think this is going to be multiplied by 100. So this is 1.75 plus I think this is going to be 1.5. So just add it up. It is going to be how much? I think 3.25. Is it clear, everybody? Yes, Poli Tejasvi. Perfect, perfect, everybody. Easy question. See the next question. Now this question again you see halwa. Yes, either it is moong dal halwa or it is suji halwa. No need to just even chew it. Just put it in your mouth and it will automatically gone. With reference to wave winding used for DC generator, state whether the following statements are true or false. The first statement is wave winding is used for high current. Now for wave winding, you know, the number of parallel paths are going to be how much? 2. Something like this. Yes or no? Suppose we are saying current in each parallel path is 10 ampere. We have fixed that. So what is the current you are getting? Total current in the armature, that is 20 ampere. Now he is saying high current and low voltage machines. Okay. Second he is saying, second statement, the efficiency of wave winding is higher as compared to lap winding. The efficiency of wave winding is higher as compared to lap winding. Suppose there are 4 number of poles. 4 number of poles. So the number of parallel paths in the lap winding is going to be equal to number of poles. Yes or no? So this is going to be wave winding and this is going to be lap winding. Again the currents are going to be 10 ampere suppose in all the parallel paths. So what is the total armature current? 40 ampere. So very easily you can understand that wave winding is going to carry less amount of current. But because all the coils are going to be connected in series in these 2 parallel paths, so the total voltage that you are getting is going to be more. Are you getting this or not? So the first statement, wave winding is used for high current, is wrong. For high current we are having lap winding. So this is going to be false. The first statement is going to be false. Then he is saying the efficiency of wave winding is higher as compared to the lap winding. Now this statement is also wrong. Whether you connect it in terms of 2 parallel paths or 4 parallel paths, accordingly the number of coils are going to be changing. The voltage and current multiplication is not going to be changed. The losses, if you see, the armature copper losses are going to be same whether it is a wave winding or lap winding. So efficiency is not going to be changing. The only difference is as per your application in terms of the high voltage, low voltage, high current, low current, you are going for wave winding or lap winding. So the second statement is also false. The efficiency of wave winding is higher as compared to lap winding is also false. So both are false. B is the correct option. Is it clear, everybody? Next question. For a synchronous generator supplying a balanced 3-phase load, the armature reaction flux is constant. Obviously, its magnitude is 1.5 phi m and it rotates at the synchronous speed. Constant and rotates at the synchronous speed. So A is the correct option. Is it clear, everybody? 3-phase 4-pole induction motor is supplied from a 50 Hz source. Find the rotor frequency when the rotor runs at 600 RPM. Now directly you have to apply, just a moment, directly you have to apply the expression or the formula for rotor speed, and R is equal to ns 1 minus s. You have to apply that. So it is going to be nr. Okay, he is asking the rotor frequency. So first you have to find the slip. How you are going to find the slip? Synchronous speed minus rotor speed divided by synchronous speed. What is the synchronous speed? Synchronous speed you can find. It is 120. What is the frequency? Operating frequency is 50 Hz. Number of poles 4. So it is going to be 1500 RPM. Are you getting that? So this is 1500 RPM minus the rotor speed is given as 600 RPM. This is again 1500. Solve this. So this is going to be how much? 900 upon 1500. So you are getting somewhere around 3 upon 5. Now can you write the rotor frequency? Yes, rotor frequency is going to be slip frequency, slip times the supply frequency. So this is 3 upon 5. Supply frequency is 50 Hertz. So it becomes 30 Hertz. It becomes 30 Hertz. What is the correct answer? C. Are you able to follow this? Everybody just tell me. Everybody just, can you like the session? And just feel that if you are sitting in the real examination, how you are going to take up the questions. Okay, don't be lackadaisical. One new vocabulary word, lackadaisical. Lackadaisical means somebody who is very lazy. Be very proactive. Which of the following is not a valid advantage not of shell type transformer over the core type transformer? See, the best reason why we go for shell type transformer is in order to reduce the leakage flux. Are you getting that or not? Yes. We have the central limb. We have the central limb in case of shell type transformer, whereas in case of core type transformer, the leakage flux is going to be more, and that is the reason losses are going to be more. So in shell type transformer, losses are less. This is the correct statement. We have to identify the incorrect statement. Mechanical strength is high. This is also correct because both the high voltage and low voltage windings are going to be placed in the central limb. So mechanically it is going to be strong. Copper requirement is less. Now this is also correct. Copper requirement is going to be less. Maintenance is easy. Now this is wrong. All these qualities are there in shell type transformer, but maintenance is going to be very difficult. Maintenance is easy for core type transformer. Is it clear? A single phase transformer has 200 primary and 700 secondary turns. If the primary voltage is this much, what is the secondary voltage? See, now what you will call it? Gajar ka halwa or moong dal halwa and or suji halwa. Which halwa? This is your transformer. Okay, this is your transformer. One side, primary side voltage is 100 volts, he is saying. Secondary side voltage you have to find. Primary side number of turn is 200. Secondary side it is 700. So what is going to be V2 upon 100? V2 upon 100 is nothing but 700 upon 200. V2 by V1 is equal to N2 by N1. Yes? Simplify this. So what is going to be V2? I think this is going to be 350. 350 volts. What is the correct answer? 350 volts. Is it clear, everybody? Yes. Poli Tejasvi, how are you? Only one candidate is able to answer in the comment box. Rest all they are just watching like a web series, movie. Okay, your life is not a web series. Life is real. Be very active. Okay. Next question. For a DC motor, the gross mechanical power developed by the motor is maximum, and the motor is supplied through a 220 volt source. Then what will be the back EMF? Generally, if you have read the concept, this is something directly you are going to solve. That is nothing but V by 2. But let us see what is the analysis. For a DC motor, I am just writing the back EMF is going to be terminal voltage minus IARA. If I have to write the gross mechanical power developed in the armature, that is nothing but back EMF. Now multiply this equation both the sides by armature current. So this is V into IA minus IA square RA. What is this back EMF multiplied by the armature current? That is nothing but the gross mechanical power developed in the armature. Are you able to follow this? So I am writing it as PM. This is V into IA minus IA square RA. Now if I want the maximum gross mechanical power to be developed. So I have to differentiate this with respect to the armature current and put it 0. dPm upon dIA. If you differentiate it, V minus 2IA RA, put it 0. So you are getting IA as V upon 2RA. Now this is the value of current at which you are getting the gross mechanical power to be maximum. He is asking about the back EMF. What is back EMF? V minus IA RA. This is V minus, what is IA? V upon 2RA. This is RA cancel. This is V by 2. What is the voltage given here? 220 volts. So 220 divided by 2 will give you 110 volts. What is the answer? B. Is it clear, everybody? Are you able to follow this? I am not able to see your faces, so I cannot see whether you are happy or not. But at least when you write something in the comment box, okay, when you are little bit energetic, then I also feel little bit motivated. So please maintain your energy, be excited about what you are doing, have a passion towards that, then only there is going to be something great happening in your life. 220 volt DC shunt motor runs at 630 rpm when the armature current is 50 ampere. Find the speed if the torque is doubled. Assume armature resistance is. Now this is the only question which I have seen in machine last year HPCL question paper, which requires you to take up your pen. Otherwise all those questions you could have solved without even taking the pen. Directly you can just answer it. Now see what he's saying. He's saying torque is doubled and it is a shunt motor. For the DC motor we are writing the torque as K phi IA. What is this K? Machine constant PZ upon 2 pi A. PZ upon 2 pi A. Is it clear? Now you are saying K is a constant, phi is a constant. Why? Because it is a shunt motor. So phi is directly proportional to the shunt field current, which is V upon RSH. Until and unless for a shunt motor you are going to change the supply voltage or the terminal voltage or the shunt field resistance, the shunt field current is not changing. Now the shunt field current is giving you the field excitation or the field flux. So field flux is also going to be constant. It means we can say this torque is going to be directly proportional to armature current. In the question he is saying the torque is doubled. Torque doubled means armature current is also doubled, because torque is directly proportional to armature current. Armature current was initially 50 amperes. So for the second case when the torque is doubled, what is the armature current? 2 into 50, that is 100 ampere. Now anytime if you have to relate the speed in case of DC machines, you have to follow the EMF. For relating the speed you follow EMF, for relating the current you have to follow the torque. So I am writing the speed relation N2 by N1. This is going to be back EMF for the second case and back EMF for the first case. Why? Because you know generated EMF for back EMF, generated EMF for the case of generator and back EMF for the case of motor is simply going to be K phi omega. Again this case PZ upon 2 pi A, that is the machine constant, phi flux is constant. So we are saying E is directly proportional to omega, where omega is 2 pi N upon 60. So can I write E is directly proportional to N? Yes. That is what I have written. Now can you write the back EMF for the two conditions? Yes, very easy. It is going to be, for the second case, what is the voltage? It is 220 minus, what is the armature current second case? 100 ampere. What is the armature resistance? 0.2. What is the back EMF we are writing for the first case? First case the current is 50 amperes, voltage is same, 220 minus, this is 50, armature resistance is same. Can you solve it? What is the speed given? Speed given is 630 rpm. I am writing here. I am writing here now. So N1 is 630. N1 speed I am writing 630, first case. Now what is going to be this value? Can you tell me? 220 minus 100 into 0.2, that is 220 minus 20, that is 200. So this is going to be 200 divided by, this is 220 minus 50 into 0.2, that is nothing but 210. So it is 210. So this is 3 times, answer is 600 RPM. Is it clear, everybody? What is the answer? The answer is, correct option is A. In this question, if you have a doubt, you can ask me. Is it clear, everybody? Are you able to follow this? Yes? Poli, how are you? Yes? Are you getting that? Everyone? I am coming out of the frame so that just you can see the whole explanation. An alternator has a per unit impedance of 0.9 per unit to a base of 20 MVA 33 kilovolt, then the per unit impedance to the base of 60 MVA and 11 kilovolt. Now this is again a halwa question. So we are writing Z per unit new. What is the relation? Z per unit old multiplied by MVA new, MVA old multiplied by kilovolt old upon kilovolt new and do the square. This is the formula you have to apply. So directly I am writing here, what is Z per unit new? 0.9, new MVA 60, old MVA 20, old kilovolt 33, new kilovolt 11, do the square. So this is going to be 0.9 multiplied by 3, and this is again 3 times, and 3 3s are 9. So just solve this. How much you are getting? $24.3. Is it clear, everybody? Yes, Mr. Jeevan. Are you able to follow this? Very easy question. Now let us talk about power system. So how you see the level of questions that you are doing, that we have done for electrical machines for HPCL exam. It is quite straightforward. Just revise your notebook, okay, your class notes. Just revise your class notes and go to the examination. You will be able to do almost 95% of the technical questions very easily. 95%, just believe I am saying this. Some 2 to 5% questions may be new to you, maybe you are not comfortable. Aptitude part, you have to be very fast. Time management is the key. Let us start with the power system. Now this was the only good question I have found in power system. The only good question I have found in power system. What is this? Annual factors are given for a power plant. Load factor, capacity factor, use factor. If the maximum demand is 20 megawatts, he is asking find the reverse capacity over and above the peak load. Now see, what is the load factor? How we are defining load factor? Average load or average demand divided by maximum demand. Yes or no? Average demand upon maximum demand. Load factor is given as 70%. Average demand we don't know. Maximum demand is given as 20. So what is going to be average demand? It is going to be 14 megawatt. Is it clear? Now he is saying capacity factor. What is capacity factor? Capacity factor we are writing as average demand divided by plant capacity. Plant capacity. So capacity factor is given as 50%. Average demand you have just solved, it is 14. So what is the plant capacity? Can you find the plant capacity? Yes, plant capacity is going to be, I am writing here, plant capacity is going to be 28 megawatt. Now he is asking, what is the reserve capacity? Now see, spinning reserve, this is also called as spinning reserve. What is the meaning of spinning reserve? Please understand, spinning reserve means your system is ready to take up this much load. It means this much power is almost generated and you can connect the load. That is called as spinning reserve, or we say reserve capacity. This is called as plant capacity minus maximum demand. What is plant capacity? 28, maximum demand 20, so this is 8 megawatts. What is the answer? B. Is it clear, everybody? Here they have also given use factor, but that is not going to be used. That is just given to confuse you, or it is just given because the question has been picked from somewhere. Okay, so use factor generally gives you the average energy, average as per the demand energy produced, okay, in certain amount of time divided by the total load connected. In terms of that, what is the energy produced, actual energy produced, and total how much energy can be supplied. But that is not useful here. Identify the non-renewable source of energy among the given options. Obviously geothermal, solar and biomass energy, these are renewable. Renewable means even if we are going to use these resources, they are not going to be exhausted. They are not going to be exhausted. And it is just a matter of relativity in terms of time. Even the power which we are getting from the sun is also limited. Yes or no? Up to what time? Suppose lakhs of years. So we don't talk like that, because lakhs of years means our average lifespan is 80 to 100 years. So from that point of view, we can say yes, solar power is going to be renewable. Yes or no? Renewable means even if you use it, even if you use that resource, this is not going to be depleted, this is not going to be exhausted. Obviously non-renewable energy source is going to be nuclear energy. Rest all are renewable. The directional element in the reactance relay is so designed that its maximum torque angle is going to be 90 degree, because you are getting this type of relation, phi v phi I, and this is sine of theta. So this torque is going to be maximum when this angle theta is going to be what? 90 degree. For the directional element, we are getting this torque equation. In an oil circuit breaker, due to heat, the oil decomposes and the gases are liberated. Which of the following gas is usually not liberated? Okay, usually not liberated. Methane, acetylene, hydrogen, these are liberated. Ammonia is not liberated. Okay. Generally, you will see ammonia is going to be liberated where human beings are going to be involved. Agriculture, okay, and other animals. So where life forms are involved, ammonia will be there. Just to give you one idea that how you can relate it, because these type of questions generally, if you are not comfortable, you have to leave in the examination. Okay. But somehow if you can relate it somewhere, then you can answer it. Take the risk. A coal-based thermal power plant electrostatic precipitator is required for ash handling. Electrostatic precipitator is required for handling the ash. Which of the following statement is wrong when the underground cables are compared with overhead lines? Underground cables means under the surface of ground, under the crust of ground, and overhead line means the lines that you see over your head, that is overhead transmission line. So overhead transmission line is going to be like this. You must have seen this when you are going on a highway trip with your family. Yes? Yes or no? These are the transmission towers. Let us give it a little bit of sag. This is overhead transmission line. And underground cable, you are going to have something like this. This is going to be the core, and this is going to be the insulator or insulation. And now this cable, underground cable, you can lay down inside the surface of earth, Now very easily you can answer this question. He is saying the erection cost of overhead transmission line is much higher. Now that is a wrong statement. Yes or no? These wires are naked wires. These are naked wires or naked conductors. You require the insulators only at the transmission tower location to give them mechanical support. But when you talk about the underground cable, the requirement of insulation is very, very high because you are keeping the conductors in the surface and you want to avoid any harm, any hazard to the nearby personnel, human being or flora and fauna. So you have to invest a lot of cost for these underground cables. Otherwise, why you will be watching all that complex network of conductors in your cities? Why not we are going for underground cables? Generally for smart cities, we are going for underground cables so that aesthetic value is very good. Your city looks very great. Yes, but it involves a lot of cost. So erection of cost of overhead transmission line is not much higher. Underground cable is much higher. So this is wrong. For long distances transmission, overhead lines are used. Yeah, this is correct. Because generally for the underground cables, you will see temperature stability, thermal stability is going to be the very important factor because the underground cables are inside the earth's surface. So temperature or thermal stability is going to be a big problem. So for long length, we generally don't go for underground cables, we go for overhead lines. Underground cables give greater safety to the public. Now this is correct because it is completely insulated. It is completely insulated. The conductor in the overhead lines are less expensive. This is also correct because you don't need the insulation all along. So A is the wrong option and he is asking the wrong option. So A is going to be the option for your question. With reference to fault analysis, line to line fault is, now this is halwa question. You remember? Suji halwa. No need to chew it, just put it in your mouth, automatically it goes. Line to line fault is unsymmetrical. Triple line to ground fault is nothing but the symmetrical fault, where ground is also involved in the fault. So this is symmetrical. So this is wrong. This is unsymmetrical line to line fault, and triple line to ground fault is going to be symmetrical. So D is the correct option. The resultant transient voltage which appears across the breaker constants at the instant of arc extension is known as. Now this question we have to read very carefully. Okay, just listen here. He is asking the resultant transient voltage. Lot of students might have done mistake in that. Yes, it is restriking voltage is the answer. What is active recovery voltage? Active recovery voltage is the instantaneous arc voltage at the time of arc interruption. The first time when you interrupt the arc, then you are getting active recovery voltage. But he is not asking that. He is not asking the instantaneous value. He is asking the resultant transient voltage. So this question was good. Okay, this question was good. If somebody is a little bit confused, then he might have given the answer as active recovery voltage. That is wrong. What is the correct answer? Restriking voltage. Is it clear, everybody? Which of the following method of tariff was proposed by John Hopkinson? Now these kind of questions, when you see it, better you leave it. If you're not comfortable, better you leave it. But the correct answer is two-part tariff. Now you must have read about this two-part tariff. It is different from your gate and engineering services preparation. It does not come into gate and engineering services preparation. This you can say tariff part. You understand what is a tariff? how the utilities are going to charge electricity from the consumer. So there are number of systems available which can be used. Two-part tariff simply tells you that there is going to be a fixed cost and there is going to be a variable component. Okay, if you see your electricity bill, you will understand that. Now we'll be going for power electronics. So just give me a moment so that I can call upon. So just give me a moment. And how you feel about the machine and power system, just tell me. Just a moment. Yes, guys, I was just correlating with Sanjay Rathi sir, your favorite, my favorite, and everybody's favorite legend. Okay, so he's a great faculty. So I was just informing him that within no time I am going to be done. So see, for power electronics, I will be just giving you the correct options. I think you can do that. Thank you, Mayank. If you like the session, thank you. Just see. I will be just giving you the answers. What is the answer you are getting for this? Single phase full bridge inverter has a supply voltage of 100 volt DC. What will be the peak reverse blocking voltage for each of these thyristors? Now I want answers from you. Okay, just tell me. I am waiting for your answer now. Just tell me in the comment section fast. Yes, everyone. Mayank, Sheikh, Poli, Jeevan. Now you have to give the answers. I will just tell you what is the correct option. Yes, it is going to be 100 volts. It is going to be B option is the correct one. 100 volts. See the next question. A single phase half wave control rectifier is supplied through a 230 volt 50 hertz supply. What will be the maximum output voltage possible? What is the correct option? Yes, everyone. It is root 2 or 230 root 2 upon pi. 230 root 2 upon pi. A is the correct option. Are you able to comment or not? Yes. See the next question. A single phase half bridge inverter has a supply voltage of 100 volt DC and a resistive load of 4 ohms. What will be the RMS output? I think this everybody can solve it. Yes. What is the answer you are getting? $50 volts. Yes. Are you doing it parallelly with me or not? After me, you will be having Sanjay Rathi sir, and then you will be having Phanindra sir. Mayan is saying 90. Please check it. Okay. Please check the calculation part. It is going to be 50. As per the source, it is going to be 50. Okay. See the next question. 2-quadrant type B chopper operates in. What is the correct answer? It is in first and fourth quadrant. So C is the correct option. C is the correct option. Are you getting Mayan? Which of the following circuit is used to obtain pulse gate triggering? Pulse gate triggering. I think it is UGT based relaxation oscillator circuit. Yes. Then next question, for a three-phase semiconductor, if the firing angle of thyristor is 90 degree, the freewheeling diode will conduct for a period of 30 degree. Directly theoretical question. Yes. Then which one of the following device does not belong to the thyristor family? What is the answer here? Yes, everyone. UJT, uni-junction transistor. Yes, A is the correct option. Next one. Which one of the following device is bidirectional? So as the name indicates, A is going to be the correct option. Yes. Then next one is, in which of the following commutation techniques the triggering of one SCR commutates the already conducting SCR and vice versa? What is the option here? Correct option. Just tell me in the comment section. Everybody. Yes, it is class C commutation. It is class C commutation. Clear? See the next question. Output voltage wave shape of a basic series inverter is, it is going to be, yes, it is, just a moment. What is the answer you are getting? Just tell me, everyone. Let me just check the correct answer. Yes, what is the answer you guys are getting? Ashish, discontinuous sine wave. I'm not sure because I don't deal with power electronics. So I'm just telling you the keys. So be sure. So let me just check. Otherwise, better you do it on your own and you can cross check it later on. Maybe I have missed the key. So this question just you check after the session, okay? After the session you can check it. Okay, no problem. So friends, now this is the time. I am going to call upon Sanjay Rakesh Sir. There will be a minute pause in between that, and Rakesh Sir is going to be connecting with you. I will be just taking your leave. So thank you so much for joining me live in this discussion. I hope you enjoyed the discussion. I wish you all the best, because HPCL examination is going to be like a litmus test for you. If you don't perform in this examination, then there is nothing to worry about. It simply means that you have not started your preparation till now, and this is the time you start. Otherwise, this examination, I think if you be little more serious for next couple of days, you can beat this examination. So all my best wishes, and let me welcome you, one of the great faculties we have pan India, Sanjay Rakesh Sir, and he is going to take forward this session, and he is going to deal with lot of subjects, and then you will be having Phanindra Sir also. Thank you so much. Thank you, Wagbi. So just a moment, guys. All the best wishes. Stay connected. Don't go anywhere. Keep on liking the session.
Hello everyone, welcome to the Byjus Exam Prep, and thank you Ashutosh Sir and Rakesh Sir for good session on HPCL. Now I am going to discuss what network and analog. So I think sound quality, picture quality, everything is fine. Please inform me that sound quality, picture quality, everything is fine. Yes. Now we are having around 15 questions from analog and what network, and that level of the question is what, just simply what 2 plus 2. What is the meaning of the 2 plus 2? 2 plus 2 means what? Simple 4. So this type of question, so very easy questions on the basic concept of network and questions on the basic concept of what? Analog, right? But these questions are important. If you have the idea about the topics, then you are able to solve this type of questions. So guys, are you ready to solve some questions on network and analog? Everyone please join the session. Yes, please. Now, I'm going to discuss the question from the network. 1 minute. This is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience, and I have qualified and selected for engineering services exam that is conducted by UPSC, and these are my ranks: AIR 16 in ESU 2005 and AIR 21 in ESU 2008, and I have mentored more than 1 lakh students for these competitive exams. Okay, now this is information for you. I'm going to take very important session because already notification out for GATE 2023. So what about the next 6 months? 6 months left for the GATE exam. What toppers do from the August? So from 1st August, what should be the strategy, right? And in this session, I'm trying to give you the answer of all your doubts related to GATE 2023. And again, we have one important session, right? That is the workshop by Abhinav Negi Sir. Now this is the first question. Everyone give me the answer for this question. Very simple one. Watch this question. This type of questions in what? HPCL exam from the network. From the network. Read this question. Two equal resistors of 10 ohm each are connected in series with a 20 volt DC supply. Find the current through the each resistor. Okay, very simple. This is a series connection of the resistor, and we are having a battery of value 20 volt, and this is a 10 ohm. This is the 10 ohm. These are connected in series. That's why the current will remain same. What is the current through the each resistor? 20 divided by 10 plus 10. These are in the series, 1 ampere. So within 5 to 10 seconds, you are able to solve this question. The answer is what? C. Answer is C, 1 ampere. This type of questions from the network. This is the first question. Then second one, the answer is what? C, 1 ampere. Now my dear friend, calculate the power absorbed by. Calculate the power absorbed by the 9 kilo ohm resistor in the following network. Now you have to calculate the power through the 9 kilo ohm resistor. Now my dear friend, we have the current source here. So how we are going to calculate the power? Power means we have the two formula, I square R or what? V square by R. You have to find the voltage across this, or simply you can find the current through this. If we are going to find the current here, then we can find the power. According to current division rule, what is the I here? I is given by 30 milliampere divided by, remember that this is the milliampere. These are the in kilo ohm, and that's why voltage will be in volt. This resistor is 9. This 6 plus 12 is what? 18. So this is the 9 plus 18. If you want current through this, then you have to multiply with what? 18. Multiply this with 18. 30 into 18 divided by what? 27. And that is divisible by what? 9. This is the 2, this is the 3, and this is the 10, and you are going to get the 20 milliampere. 20 milliampere is the current through what? Current through 9 kilo ohm resistor. So what is the answer for this question? Everyone give me the answer in the comments box. So if the 20 milliampere is the current, then what is the power? The power is very simple thing. 9 I square. What is this? 20 square into R, 9 kilo ohm. Right? Then my dear friend, we are going to get the 3600. But remember, this is the milliwatt. Remember, this is in what? Milliwatt. Always remember, if the current is in milliampere, resistor in kilo ohm, voltage in what? Volt. Then the power, it is what, in milliwatt, that is in milliwatt, power will be in milliwatt, always remember. Voltage in volt, resistor in kilo ohm, then current will be in milliampere, and when we are going to calculate the power, it will be in milliwatt. So 3600 milliwatt means what? 3.6 watt. Very simple question. The answer for this question is what? D. D for Delhi. So this is the answer, 3.6 watt for this question. Right. The next question, 1 minute. Yes. Now, next one from the steady state analysis of sinusoidal signal. Let's watch this. If a voltage V, 10 cos of 100 t plus 30 degree, if that voltage is given with the phase shift what? 30 degree. What is the phase of this voltage? So normally we are representing like this, V is equal to Vm cos of omega t plus what? Phi V. So what is the omega here? 100 radian per second, right? And phi V is 30 degree. So how to solve this type of questions? Is applied to a 50 microfarad capacitor. Okay, if it is applied to the 50 microfarad capacitor, same voltage is applied to the 50 microfarad capacitor. This is the C, this is V. Now normally the student will calculate what? ZC. What is the ZC is equal to minus J by omega C. Then they will find the current. What is the current? V by ZC. And then they will find the angle. But watch the answer. In all the answer, amplitude of the current is same. So no need to calculate the amplitude of the impedance. This function is same, cos of 100 pi t, cos of 100 pi t. Only you have to check the angle. Always remember, capacitor is a leading circuit, or when there is a current through the capacitor IC, it will lead the applied voltage. IC lead applied voltage by 90 degree. Simple. So what is the angle here? 30 degree. You have to add 30 plus 90. So this internal part will become cos of 100 t plus 30 degree plus 90 degree. And this is Im. So what is the answer here? Im cos of 100 t plus what? 120 degree. No need to calculate Im. Why? Because in every answer Im is same. So within 20 seconds you are able to solve this question. Yes or no? Within 20 seconds you can solve this question. Answer is what? C. The answer is C. So simply watch. If it is a capacitive circuit, current will lead by 90 degree. If it is a inductive, pure inductor, current will lag by the 90 degree. Current will lag by the 90 degree. So we are adding the 90 degree here. Now next one. So that is the answer, 50 cos of 100 t plus 120. Now everyone, power amplifier. Arey bhai ek bar zara please like the session, share the link of this session, okay, so that student will join. Because just I want to give you the idea which type of questions you may expect in what HPCL. No doubt these all questions are easy, but chance of what? Silly mistakes. Syllabus is very vast. You have to get the idea about the complete syllabus, but depth knowledge is not required. Only the knowledge up to what surface level is required for this type of paper. Okay, so no need to solve the previous year question of GATE exam for this particular HPCL. Simply go through the basics of all the subjects and you are able to solve the questions. And that's why we are discussing this paper, so that you will get the idea. Right. A power amplifier supplies 50 watt. No doubt word here written is what? Power amplifier. But it may be related to what? Analog, or it may be related to other subject, but it is a basic question from what? Network or circuit theory. So one student have given the answer, that is what? D. Ashish. Yes, you have given the answer D. Okay. Yes, Ashish. Now, power amplifier supplies 50 watt to an 8 ohm speaker. Normally, when we are using the loudspeaker, the what is the weight resistance of that speaker. Remember that it is in the range of what? Ohm only. It is in the range of ohm only. Find the AC output voltage and AC output current. So what is the AC output voltage and AC output current? Already I have given. What is the power means? V square by R. So what is the voltage is equal to? Root over PR. Very simple, right? Or this is also VI, or this is also I square R. So that is the relation between the voltage and power. Root over PR means what? Root over 50 into 8. Root of 400. What is the root of 400? 20 volt. Once you are going to get the V, you can use this formula. 50 watt is equal to V. What is the V? 20 into I. So what is the I is equal to? 50 by 20. That is nothing but 2.5 ampere. 2.5 ampere. So remember this formula for the power, V square by R, VI or I square R. By using this formula, you can find the value. So voltage is what? 20 volt and current is what? 2.5 ampere through the 8 ohm speaker. So this is the answer for this question. Okay then. Next one everyone. So this type of question, that is the answer D for this particular question. And the PDF for this session will be available on our Telegram channel. So please join our Telegram channel. My Telegram channel is Electronics by Sanjay Rathi. Okay. So join that channel. I will upload the PDF after the class. So, but before that, try to give me the answer. A 2 kilo ohm resistor is connected across a 10 volt battery. Calculate the power consumed by the resistor. 2 kilo ohm resistor is connected across a 10 volt battery. Calculate the power consumed by the resistor. Again, similar type of questions. We are connecting. Third question on power calculation. This is the resistor 2 kilo ohm. Right? What is the battery? 10 volt. What is the power here? Power is given by V square by R. This is 10 into 10 divided by R, that is the 2 kilo ohm. Already I have given that if you are having the resistor in what? If you are having the resistor in kilo ohm, then power will be in what? Milliwatt. Power will be in milliwatt and current will be in milliampere. Here we are having the 2 kilo ohm, no need to change. What is the answer for this question? 100 divided by 2 kilo ohm, that is nothing but 50 milliwatt. Or suppose you are trying to solve, we are wasting our time, means what? 10 into 10. First of all, I will convert this resistor into ohm. It will become 2000 ohm. This will become 2000 ohm. Then I will solve it. You are going to get the 1 by 20 watt. Then you will multiply it with 100,000. So that you are giving milliwatt. So very time consuming. It will consume your time. So remember that if the current is in milliampere, resistor in kilo ohm, voltage in volt, power directly in milliwatt. Power it will be in milliwatt. Directly you can use this formula. Right. So answer for this question is D, again 50 milliwatt. 50 milliwatt. You can check my calculation. Answer is 50 milliwatt. Next one. Next question, guys. Ready? Okay then. A Thevenin circuit has a VTH 20 volt and RTH 20 ohm. Means now the question on theorems. Thevenin's theorem. This is a Thevenin's and Norton's and maximum power transfer theorem. Always remember these three theorems are very, very important. Normally we are expecting question from this. Thevenin's, Norton's and what? Maximum power transfer theorem. No doubt we can expect question from what other theorems just like superposition theorem or what reciprocity, Telegans. Okay, but these three are very, very important one. Thevenin's circuit has VTH is equal to 20 volt, RTH 20 ohm. Find the maximum power transfer to the load resistance of 20 ohm. What will be the maximum power? So according to maximum power transfer theorem, according to the maximum power transfer theorem, if you are having the RTH, if you are having the VTH, then this RL, should be exactly equal to RTH. And what is the value of the RTH? 20 ohm. And this VTH is given as 20 volt. This RL should be equal to what? RTH for maximum power transfer to the RL. So what is the value of RL given here? 20 ohm it is given. Means it will satisfy the condition RL should be equal to RTH. So it will satisfy the maximum power transfer theorem condition. Now if it is this is the case, then what is the maximum power? Maximum power is given by VTH square by 4 RTH. That is the formula. VTH square by 4 RTH. So what is the VTH here? 20 into 20 divided by 20 into 20 divided by 4 into 20. 4 into 20. This 20 cancel, and what is the answer? 5 watt. Answer is what? 5 watt. Very simple. So directly within 20 seconds you are able to solve this type of questions. Remember that VTH square by 4 RTH is the maximum power. RTH, RL should be equal to RTH. And what will be the efficiency of the system? Everyone give me the answer in comments box. If that is the case, then what is the efficiency? How much power is given to RL? How much power is wasted across the RTH? And what is the efficiency of the system? Okay. Next question. Give me the answer in comments box. The answer is 5 watt. Now, next one is the dual of Norton's theorem. Dual of Norton's theorem. Okay, this is a very, very easy question. Thevenin's equivalent and Norton's equivalent. Thevenin's equivalent and Norton's equivalent. When we are finding, these are called what? Source transformable pair. Source transformable pair means, let this is the Thevenin's equivalent. VTH, and that is the RTH, and this is what? Norton's equivalent. Right, IN and RN. So this is the answer. So we can find answer for this question is what? Thevenin's theorem. Okay, dual of Norton's theorem. Okay. From one theorem we are going to get the VTH and RTH. From other theorem we are going to get what? IN and RN. Okay, this is a current source, parallel is RN. This is called Norton's resistance, and this is the VTH, and that is called RTH. So this is the Thevenin's theorem. Now next one. Are you watching? What about the level of the question? Everyone tell me. What about the level of question? Easy, moderate, tough, or very high, or what should be the last option? Filling the blanks. Very easy. But no doubt, too easy, na? Yes, very easy questions. But my dear friend, in exam hall, in 2 hours 30 minutes, 2 hours 30 minutes, we have to solve 170 questions, 85 questions from technical portion and 85 questions from non-technical portion, right? And there may be the chance of what? Silly mistakes. Then what? Try to solve all the questions with full confidence, okay? And try to avoid silly mistakes. Try to avoid the silly mistakes. So this is the Thevenin's theorem. Next one. Answer is Thevenin's. Now, find the coefficient of coupling for the two coils having the L1 is equal to 2 Henry, L2 is equal to 8 Henry, and mutual inductance is what? 4 Henry. What is the coefficient of the coupling when we are having the inductor like this? This is the L2, this is the L1, and we are having the mutual inductance in between these two, M. Then the coefficient of coupling is given by K is equal to M divided by root over L1 L2. This is the standard formula. K is equal to M divided by root over L1 L2. What is the M given here? 4. Root over 2 into 8, that is the 16. What is the root of the 16? What is the root of the 16? That is nothing but 4. 4 divided by root 16, that is the 4 divided by 4, it is 1. Okay, answer for this question is Ashish, Purva. Yes, 1 minute. I want to watch your name. Yes, Purva Mazumdar. Your answer is correct. Answers are correct, and that is what 1. And tell me, what is the ideal value of the k? Ideal and highest value of the k is 1. 0 is less than k is less than what? 1. If it is less than 5.5, it is called loosely coupled. Loosely coupled. Right? And if it is greater than 0.5, it is called tightly coupled. Tightly coupled. Okay. So normally we are using the air core transformer and iron core transformer. So in air core transformer it is loosely coupled, and iron core transformer is what? Tightly coupled. The K is normally greater than 0.5 for right, iron core transformer. So remember, these type of questions we may expect from this mutual inductance or coupled circuit. Okay, then the answer is very simple, 1. Ideal value is 1. Now tell me, that is the simple question on what circuit? Within 30 seconds, give me the answer. Find the value of the Thevenin's resistance RTH for the circuit to the left of the terminal A and B. To the left of the terminal A and B, find the resistance RTH. Now, when we have to find the RTH, first of all independent sources should be equal to 0. All independent sources should be tends to 0. Tends to 0. Means this 32 volt tends to 0. So when the voltage source tends to 0, it should act as what? Short circuit. When the current source tends to 0, it should act as what? Open circuit. So it should act as short circuit, it should act as what? Open circuit. Now tell me, what is the answer? When it acts as short circuit, make it short circuit. And this should act as what? Open circuit. Make it open circuit. Okay. Remove the RL. Always remove the RL. Remember that. Always remove the RL. And then you have to find the equivalent resistor across A and B. When I am going to find the equivalent resistor across A and B, 4 and 12 are in parallel and 1 is in series. So what is the resistance seen here? The RTH is nothing but 4 parallel with the 12 plus 1. 3 plus 1, that is nothing but 4 ohm. The Thevenin's resistance is what? Simply 4 ohm. So that is the method. This answer is what? 4 ohm. Simple question. Okay. And now next question. So you can practice this type of questions. Already I have given a number of questions on my session. Again, if you want complete revision of what this subject and analog, this Wednesday, please note the time. Wednesday from 11 to 1 p.m. means around 2 hour session. I am going to discuss around 35 to 40 questions from analog. I will cover each and every topic from the analog, and so that you will get the idea which type of questions we may expect. How many students are interested? If you are interested, then please subscribe our channel and like this session, okay, so that you will get the notification. So this Wednesday, 35 to 40 questions from analog, from almost 2 questions from every topic, so that you will get the idea. 2 and more questions from every topic. Clipper, clamper, voltage regulator, right, or what transistor, MOSFET we will cover here. Okay, so answer is what? 4 ohm. Now again a very, very simple question. 9 volt battery supplies a 1 milliampere current in a series circuit of 3 resistors. Directly you have to make the circuit. This is the R1, this is the R2, this is the R3. These 3 resistors are connected in series. If the voltage drop across 1 volt, 2 volt and 6 volt, 1 volt, 2 volt, 6 volt, right, 9 volt battery is connected here, and current is also given. Current is also given. In series the current will remain same. you have to find the value of R1, R2 and R3. This type of questions, my dear students, if this is given 1 volt, so what is the V1 is equal to? IR1, that is given as 1 volt. So what is the value of the R1? 1 divided by 1 milliampere, that is nothing but 1 kilo ohm. What is the V2? IR2, because in the series the current will remain same, that is given as 2 volt. So what is the value of the R2? 2 divided by 1 milliampere, that is the 2 kilo ohm. And now my dear friend, what is the V3? IR3, that is given as 6 volt. So what is the R3 is equal to 6 divided by 1, because I is 1 milliampere, it will become 6 kilo ohm. Always remember, if the current is given in milliampere, resistance will be in what? Kilo ohm, and voltage in volt. So this is the answer. Now everyone give me the answer in comments. How much time is required to solve this type of questions? Read question carefully. Right, and suppose we are watching the battery, we are going to find the current here, but already current is given. You are going to use the voltage division rule, but already voltage is given. No need to find the voltage. Voltage is given, current is given, simply we have to find the current. But the number of students will trap into what? Voltage division rule or other method. Right? 20 seconds, maximum 20 seconds for this type of questions. Now, next one. Oh, very simple. Find the value of Z11 for the following network. Find the value of the Z11 for the following network. Everyone, please give me the answer in the comments box. What is the answer? And give me 1 minute. Okay guys, now what is the answer for this one? What is the answer for this question? Ashish have given the answer D. Find the value of Z11 for the following network. This is actually it is a part of what two-port network, T network. What is the T network here? Like this. Everyone, you have the idea about the T network. This is the I2, this is the V2, this is the I1, this is the V1, and that is what ZA, ZB and what ZC. So what is the Z11? Z11 and Z11 is equal to ZA plus ZB. Z12 is equal to Z21 is equal to what? ZB. And what is the Z22 is equal to ZB plus ZC. But here the ZC, what is the value of the ZC here? 0. It is a short circuit. And what is asked here? Z11 only. So Z11 is what? 16 plus 12. This is nothing but ZA and this is nothing but ZB. So 16 plus 12, it is 28. So answer for this question is 28. Directly only one thing is asked. What is the value of Z11 in this question? Okay then. Next one. Next question. The answer is 28. Now this is all about the network. Now I am going to start what? Analog. Only we have the 4 questions from the analog, but that is information for you. 6 months left for GATE. What toppers do from the August? Today at 11 p.m. 11 p.m. on the same channel. I will explain each and everything. Oh sorry, 10:45, not 11 p.m. 10:45. So please stay tuned with us and subscribe our channel, and I will share all complete strategy for next 6 months. Okay. Then analog. Questions from analog. Again, very easy questions from the analog. Following circuit is a diode circuit and application of the diode circuit. Always remember this topic is very important. Clipper, clamper, voltage doubler and what voltage regulator, rectifiers. So this is the question from the clipper. Okay, it is a series negative clipper, series positive clipper, shunt positive clipper, shunt negative clipper. Try to understand. Series means what is the position of the diode with respect to load. With respect to load means we are having two types of the clipper. First of all, this one. Second, watch this diagram. We are having R. Here we are having the diode. Here we are having the reference voltage. That is first case. Second case, here we are having the diode. Here it is R, reference voltage, and that is the case. Actually, here we are connecting the load. Here we are connecting the load. So with respect to this load, the diode is in parallel, and that's why it is called shunt clipper. Shunt. And in this case, the diode is in a position with what? With respect to RL. It is in series. It is in series like this. This type of clipper is called series clipper. So that is the shunt, this is the series. And that's why this diode is connected parallel to RL. And that's why it is a shunt. Now, positive or negative, if it will cut a portion above some reference level, then it is called positive clipper. So always remember, when this type of diode, you can write here what is the VI, what is the position of the diode, and what will be the output. When the VI is less than 0, negative, the diode is off. When the diode is off, output will be exactly replica of the input. V0 is equal to Vi. Output is exactly replica, means it will pass the negative portion. At the same time, when it is greater than 0, diode is on. Once the diode is on, it will act as short circuit, and what will be the output? 0. Means it will block the positive portion. Or when it will block or when it will cut the positive portion, then it is called positive clipper. If it will cut the negative portion, then it is called negative clipper. If it will cut the positive portion, then it is called positive clipper. So what is the name of this circuit? Positive, shunt positive clipper. Shunt positive clipper. Right? So that is the waveform. If suppose it is a sinusoidal signal, it will pass the negative portion, but it will block the positive portion. We are going to get this type of negative portion. So actually it is a half wave rectifier, because it will pass the negative half and it will block the positive half. So we can say it is a special case of what? Half wave rectifier. That is a clipper. Okay. So answer is what? Shunt positive clipper. Now second thing, if we have simply changed the position of the or polarity of the diode, it will become shunt negative clipper. It will become what? Shunt negative clipper. Simply change the polarity of the diode here. So this type of questions I am going to discuss on Wednesday, each and everything about the analog, right? And today we are going to discuss only the paper, so that you will get the idea what will be the level of the question paper. So that is the level, very easy. On Wednesday at 11 p.m. 11 a.m. I am going to discuss number of questions on this topic. So this is a shunt positive clipper. Now RC phase shift oscillator means question from the oscillator. RC phase shift, Wien bridge oscillator, Hartley, Colpit, Clap, Crystal. These are the oscillators. So oscillator, an RC phase shift oscillator, find the value of the resistance R to produce the frequency of 1000 kilohertz. Always remember, in case of RC phase shift oscillator, frequency of oscillation is given by 1 by 2 pi, right, root 6 RC. 1 by 2 pi root 6. This is the standard formula. You have to revise this. 1 by 2 pi root 6 RC. So what is the F0? It is given here. F0 is given. Find the value of the resistance if 100 kilohertz. 100 kilohertz means 1000 kilohertz, sorry. 1000 kilohertz, 10 to the power 3. This is in hertz. 1 by 2 pi root 6 you have to find the R. What is the value of the C? C is 1 by root 6 pi into 10 to the power minus 12 into 10 to the power minus 12. This root 6 cancel, this pi is cancel. You have to calculate the R. So what is the R is equal to, this will become 10 to the power 12 divided by 2 into 10 to the power 6. Now my dear friends, solve this. This is the, you are going to get the answer 500 kilo ohm. 500 kilo ohm. Simple calculation. Please try to avoid the calculation mistakes. That's why I am doing this much calculation. Very simple, cut here. This is the R here. Now this value is here. And directly 10 to the power 6 upon 2, that is nothing but 500 kilo ohm is the value of the resistor. Okay then. And remember the formula of what? Win bridge oscillator also. Now next one. 500 kilo ohm is the answer for this question. Very easy question. For a transistor, if the beta is 49, find the value of the alpha. This type of questions. Give me the answer. Beta is 49. What is alpha? So what is the relation between beta and alpha? Beta is equal to alpha 1 minus alpha, or alpha is equal to beta upon 1 plus beta. So 49 divided by 1 plus 49. That is 49 divided by 50. If you are going to solve, you are going to get the 0.98, nearly equal to 1. It is visible. 49 divided by 50, it means what? 49 or 50 is almost equal, nearly equal to 1. Which answer? B. But proper calculation. 49 divided by 50, you are going to get the 0.98 because we are having the 0.99 also. 0.99 also. To proper calculation. So that is the D. Now, next. For a transistor, collector current is 100 times the base current. Collector current is 100 times the base current. So what is the collector current? IC is 100 times of the base current. Then what will be the value of the beta? What is the formula? IC is equal to beta IB plus 1 plus beta times of ICO in active region. This is ICO is the reverse saturation current. It is not given in the question. Neglect it because it is very small. Neglect this. So IC is equal to beta IB. These all are the DC. This is the DC, this is the DC, this is also DC. Compare these two equations. What is the value of the beta? 100. Direct question. Direct 100. Within 10 seconds. Within 10 seconds you can give the answer. 100 is the answer for this particular question. Now, easy guys. So this is all about analog, right? Now I'm going to stop it. Now the Phanindra sir will join, right? And he will discuss questions from what? That is the measurement portion. Okay. So ready guys? And this is for you. 6 months left for GATE exam. What toppers do from the August. Okay. Please join the session till the end of this session so that you will get the idea which type of questions you may expect in HPCL exam. And this is very important. No doubt questions are very easy, but definitely knowledge of the subject, basic knowledge of the subject is required. Okay guys, please wait just for few seconds and the Phanindra sir will join you. Okay. Then this is a free workshop, step-by-step guidance from the Abhinav Negi sir. Join this session on 30th July at 8 PM. Register here for this session. Okay. Now, Phanindra sir will start with measurement. Thank you. And good luck for all coming exams. Thank you very much.
Hello. Welcome to everyone to this beautiful session. First of all, thanks to Rakesh Sir and Ashutosh Sir and Sanjay Sir for their wonderful, valuable suggestions as well as the lecture. So we all have gathered together to discuss the questions related to HPCL which were asked in the 2021, and I am here to present two subjects. One is measurements and then control system. And you may be worrying about the practice question. Don't worry, at the end of this lecture I will also give some of the homework also. So let's be together till the end of the session. I am very sure that I will going to justify the two subjects, measurements as well as control system. Guys, tell me, are you ready for this remaining two subjects or not? Or you really got bored, or you might be really worried to go for the lunch? So even then, stay with me for 20 to 25 minutes. I will wind up the session. Okay, right. So before going to the session, let me quickly introduce about myself to the students who are not familiar about me. As you all can see, myself Phanindra, all put together I have an experience of 11+ years teaching experience, and if you see, all put together up to now I have taught more than 50,000 students all across the country, and I am specialized in control systems, measurements and industrial instrumentation. So in this lecture I am going to take the questions on these two subjects, that are control system as well as measurements. Again I am saying I want the interaction from you whenever I ask the answer. So please let me know whatever the solution you got it. So that will motivate me and give the energy to me, naturally that will benefit you. Correct? So let's get into the first question, that is of course from the measurement subject. You all can see on the slide, electrostatic type instruments are primarily used as dash. So this seems to be very easy question as far as the gate structure and the syllabus is considered, and all the teachers so far they have been continuously saying that, especially the questions which were asked in the HPCL are very easy compared to the gate standard. Correct? So what would be the correct answer? Any one of you, can you answer here? So many students are there. Ashish is there, Pooja is there, Arka, Pova. So many students are there, so you can answer here. So I will be waiting for your reply. What would be the correct answer here? Right? That is, electrostatic type instruments are primarily used to measure dash. Right? So let me tell you in a simple way. Suppose let us say you have two plates here. Assume that there is a plate here, and consider that there is another plate. Assume that these two are metal plates. Okay, these two are metal plates, and what I do is somehow I will charge this as a positive charge. Consider that somehow some mechanism I used to charge one plate, that means the first plate as a positive charge and the second plate as a negative charge. Correct? So if I say this is negative charge, then you all can say from the Coulomb's law there exists a electric field between the positive charge and a negative charge, right? So there is a strong force of attraction that happens between both the plates. Correct? So what brilliantly people do is they will fix this plate. Suppose let us say this plate is fixed. Okay, let me call this plate is a fixed plate, and however if I say this particular plate is a movable plate, okay, so if I say this is movable plate, and for time being what I do is for this negative plate successfully I will add a spring here and connect to the raised surface here. So now tell me what will going to happen. Every one of you please answer here. So what will going to happen? So you can see here a negative plate here, all the way it is connected to the spring, right? And this is a fixed plate. Then obviously because of the electric field a strong force of attraction will be there, and because of that I can say this plate will going to move in the left direction. Correct? So this will be attracted strong, and when it is getting attracted strongly, then naturally the spring will going to displace in the left direction. Correct? So what happens if I say, for example, let us say that I have some scale here. So let us consider that there is a scale here all put together. So therefore I can say if there is a scale, then naturally the amount of the attraction, suppose depending upon the force of attraction on this side, so naturally it will going to displace left side. When it is getting displaced on the left side, then naturally the pointer which I have been speaking continuously here, that will going to shift its motion here. Correct? So that will indicate a different value on the scale, right? So this is how the scale reading. Now if you see, if I say the pointer is marked somewhere here, what does it mean? The plate is all the way it came up to here. Correct? So what it is indicating? Can you tell me? The reading on the pointer or the reading on the scale, it basically indicates the amount of the displacement here. And the amount of the displacement, basically it is a result of the force of attraction, right? And force of attraction is the result of the electric field, and the electric field is the result of the charge, and the charge is the result of the voltage. Clear? So I repeat back, the scale indication right? So let me write down here scale indication all put together. I should say the scale indication is the result of what? Scale indication is the result of x, that is the displacement of the spring or the elongation of the spring here, and the spring motion or the displacement in the spring is the result of the force here, and force is the result of what? Electric field, as I said, and the electric field is the result of charge, and the charge accumulation is the result of the applied voltage. Clear? So suppose if you want to measure the voltage, let us say if I want to know the amount of the voltage what I have applied here, because if you can understand here, the voltage is finally converted to a scale indication, correct? What does it mean? If the voltage is converted to the scale indication, from the scale indication or from the indicated value in the scale, I can directly say what is the voltage here, correct? So that's why I can say all the way that electrostatic type instruments are used in the voltmeter. Clear? I have given a very fundamental idea for the linear motion. However, if you are really interested to see the practical diagram of this, so it looks like this all the way. You can see there is a fixed plate here, right? So that will be charged positive or negative, whatever it may be, and the other plate will be oppositely charged, and we have a spring, right? So naturally, when there is a force of attraction because of the electric field between both of these two plates, then the pointer will go into rotate here. Clear? And the force of attraction between both of these two plates is going to depend upon the amount of the voltage that we applied here, and that is called as a measured voltage. Clear? The more the voltage we apply, the more the force of attraction and the more the indication on the scale. This is how exactly we do the things. I hope you are getting the clarity about this. Now move on to the next one, that which of the following, look at this second statement, which of the following characteristics is not desirable in measuring instrument. Clear? So that means when you go to the market and when we buy the instrument, so there will be some characteristics that will be given, starting like range, span, sensitivity, drift, and many things, correct? So they are asking what would be the desirable, not desirable. This is a really good question, not desirable. So that means which characteristic you want. First of all, look at the options here. So we all know that the accuracy is the prime importance, right? We want the accurate instrument. So if you want accurate instrument, here the question is not desirable characteristics, because we know that the accuracy is a desirable quantity, and similarly linearity is also a desirable quantity, because we always expect any device what we are using in engineering must be linear as much as it can, correct? So naturally these two are very much desirable characters, so they cannot be the options. Linearity is a desirable characteristic and accuracy is also desirable characteristic, but the question is about not desirable or non-desirable. Clear? So then repeatability. What do you mean by repeatability? It is also very simple. Repeatability means whether the instrument is showing the same reading for the same input even if the operating conditions are changed, or even if you take number of readings, correct? So suppose let us say I am measuring 5 volt voltage, and if your voltmeter is showing 4.99, even again if I use the same meter in the same room, in same city, at same environmental conditions, once again if it is showing the same 4.99 for 5 volt indication, 5 volt measurement, then I can say that is repeatable. Clear? So that's good, right? So because if it is showing the same repetition for the same input, I can say that is almost reliable there, right? So that's why I could say that repeatability is also a very important characteristic. Repeatability means how well it can be repeated, or how well the instrument is able to repeat the same output for the same input even if you do 10 times or 20 times, n times experiment. Clear? So what is the non-desirable quantity? The only option that is left here is the drift, correct? So usually drift is actually nothing but the increment from the expected value. Clear? Suppose for example if I say zero drift, for example I need to take some example. If I take zero drift, if I say any instrument is calibrated as y is equal to mx plus c, correct? So what you will understand here, if I say the input value here in this particular case, if I say the input x is equal to 0, if the input x is equal to 0, then straight away y will be equal to c here. Clear? So this means that whenever there is no input, even though there is no input, we are getting some output, but it should not be the case, correct? Correct or not? Because when we switch off the input, output also must be switched off. But in this case, even when you switch off the input, we are getting some output at the end, and this is considered as a zero drift here, and some people used to call this as a offset. Clear? So that is what we don't want, because when we don't apply the input, we generally and genuinely we expect that the output must be equal to 0. Clear? So all of you please tell me, is it clear so far? Every one of you must answer this, right? Hope all of you are following. So first thing is, it is going to be zero drift is the answer here, right? So then moving ahead to the next question, that all of you please see here, right? So in the cathode ray tube, the distance of dash is minimum from the phosphor screen. So I hope every student who is following the classes, they might be knowing about the CRO and CRT, right? So CRT is conventionally an instrument which is there in the CRO. Now this is the way how the internal structure of the CRT tube looks like, cathode ray tube. Now have you seen? First of all, we will be having the cathode here. So let me take some other color here. So we are having the cathode which generates the electrons here, and electrons will travel through the grid, and we have focusing anode and accelerating anode. All these things will do their job here. All the way the electron beam will pass in this way like this, and now you can see vertical deflection plates. What they do? They will going to move the suppose if you say vertical deflection plate, this is the way how it looks like, correct? So you all can see. So if the vertical deflection plates are like this, then the electron beam, whatever is coming here, it can actually deflect like this, right? So because if you apply more positive voltage and negative voltage here to the vertical deflection plate, it is quite logical that the electron beam will going to move in the vertical direction, correct? And to accelerate on the screen in the linear direction, right? So because if you see the CRO screen here, so there will be so many things like this, right? So you can see this is a grid of the CRO screen all put together. Now if you apply the voltage to the vertical deflection plate, maybe the spot may increase like this, correct? But to move horizontally, we require horizontal deflection plates. Clear? So if you see, horizontal deflection plates are placed in such a way that they are parallel to each other, and especially they will be like this. Clear? So you all can see here. So give me 1 second time. Right, so the horizontal deflection plates will be like this. Every one of you please see, and you all can see this deflection. After vertical deflection, the beam will all the way travel through the horizontal deflection plate. However, the question you can see, horizontal deflection plates are the one which are very near to the phosphorus screen. Even you can see the diagram here, and this is your phosphorus screen here, and near to phosphorus screen we are having the horizontal deflection plates. So the idea is simple. Even though you might not be knowing exactly even though you might not be knowing exactly what is the use of horizontal plates and vertical plates, you might be understanding that the vertical plates are far away from the phosphorus screen, whereas the horizontal plates are very much near to the phosphorus screen. See, there are so many students in the live session, so you must actually give me the correct answer and reply, because as I said, your interaction must give the energy to me. If it gives the energy to me, I will give more guidance to you. Okay, so every one of you answer here without failing this, right? So I hope you got the point here. Now let's move on to the next one, that which of the following is not the characteristics of the PMMC. See, we all know that the PMMC is considered as a permanent magnet moving coil, correct? First of all, it is a very simple device, correct? It is a very simple device. And second thing is, it can measure only DC signal or the average value of the complete input signal or complete voltage or current, whatever you are measuring here. And more importantly, we know that the coil will going to rotate inside the magnetic field. Correct? When the coil is rotating inside the magnetic field, naturally, because of the mechanical motion, we will be having the hysteresis loss, right? We will be having the hysteresis loss. But what is giving here? It is given like a no hysteresis loss, right? So we will be having very small, that is the meaning. Yes, very small hysteresis loss, right? Small. So that's why people even neglect that, yes, there is no hysteresis loss, right? Because lightweight coil we are going to have. So when we are having the very lightweight coil, usually we can expect that there is no hysteresis loss because of its rotation. Clear? So obviously this statement, because here it was mentioned that not a characteristic, right? So that means you should select an option which is actually not the relevant to the PMMC here, correct? So now you tell me, if it is not relevant to the PMMC, the very first thing, as I said, it is used for the DC measurements only. It is relevant, so it would not be the answer, correct? It would not be the answer. And high accuracy, yes, we know that the PMMC is the accurate device, right? Because iska pass, magnetic flux, magnetic field, not too much worry about that, because the RMS meters requires to measure the AC signal, and when we are measuring AC signal, there are a lot of troubles will come. But in the measurement of DC, we don't face so much of difficulty. So this is also not the option. Then what is the, of course, I told you that no hysteresis loss, right? So yes, of course, because no hysteresis loss is a characteristic of the PMMC. But the question is not a characteristic of the PMMC. Then obviously A is the only option that is left, non-uniform scale. Clear? Because the PMMC usually has a uniform scale. Clear? But it was mentioned that non-uniform scale. Correct? So option A is the right answer for this question. Let's move on to the next one here. That is a 0 to 200 volt voltmeter has a guaranteed accuracy of 0.5% of the full scale. Clear? So first of all, let us take the reading here. Voltmeter reading, let me write down here. So voltmeter reading, first of all, you all can see that it was mentioned as a 0 to 200 volt, correct? 0 to 200 volt plus or minus 0.5% of the full scale. So 0.5% of what? It was mentioned full scale is 200 volt, correct? So then what can I say? How can I change this one? So it's very easy now, right? So 0 to 200 volt plus or minus 0.5% of 200 volt is how much? Look at that, because this full scale voltage is this one. This 200 volt is considered as a full scale deflection, and you are here to understand the fact that the 0.5% of this one, what is the value? 0.5% of 200, it is actually nothing but 1 volt. Clear? So simple. 0.5% of 200 is 1 volt here, correct? So this means this is the guarantee error that you will going to get, correct? So let me say, so here as it was mentioned that yes, this is a guarantee error you will going to get wherever you are going to measure or whatever the value you are going to measure, right? Now he himself is saying that he is planning to measure 50 volt, correct? So that means, so the voltage measured by the instrument is 50 volt, correct? So if it is measured 50 volt, there is a possibility to have 1 volt error here, correct? So therefore, sorry, percentage of limiting error can be written as, clear? The possible error what we can get here divided by the value what we are supposed to measure, that is 50 volt here, right, into 100. So what is the guarantee error that we have seen here? So can you tell me fatapat here? So it is going to be plus or minus 1 volt divided by 50 volt into 100. So as I was saying, it will going to be equal to plus or minus 2%. Clear? So what would be the correct answer here? Any one of you? Fast. Many students are there. You are giving the answers. So please give me the answer, correct answer here, every one of you. So you can see plus or minus 2% is the correct answer, and that is there in the option C. Clear? Now moving to the next one. This is a so easy question. Whenever I see this question, I really feel that such a easy paper this is, right? HPCL, right? So a conventional oscilloscope has a bandwidth of 100 MHz. First of all, the rise time of the CRO is approximately dashed. Again, this is also a very simple question. So how can I write this one? That first of all, rise time, that could be written here clearly as rise time is equal to, what should I say, 0.35 divided by the bandwidth, right? So this is the most common formula regularly we use, 3 dB bandwidth this is, right? And even it is very important in not only for the semester exam of the engineering graduates, it is also equally important for the GATE examination, right? So rise time, we usually write this as a TR, correct? That is equal to 0.35 divided by bandwidth, and as I was saying earlier, 0.35 as usually we will write like this. However, the bandwidth is 100 MHz, right? So 100 into 10 to the power of 6 here, right? So moving ahead, it will be like 0.35 divided by 10 power 8 here, correct? So therefore I can say here that is 0.35 into 10 to the power of minus 8. This is what you will be getting here, correct? So therefore, what should I say here? So this is equivalent to what? 3.5 into 10 to the power of minus 9 seconds. So 3.5 nanoseconds is the correct answer for this question, and again this is a very simple question, correct? So 3.5 nanoseconds, option A is the correct answer, and you should appreciate really HPCL for asking these small questions. But anyway, as I said, if questions are small, it's quite difficult to crack the exam, because even if you miss a single question or if you answer wrongly single question, you will be under trouble, correct? So let's go to the next one, that in induction type energy meter, dash error is caused due to the overcompensation of the friction, right? So it is a straight away direct question here. So we all know that this is the way how it looks like, and we will be having the shunt magnet, and exactly the disc is between the north pole and south pole, and the disc is about to rotate, correct? So we have seen several times that if there is no load current here, suppose if I say IL, load current is equal to 0 ampere, because of the heavy voltage that we have applied to the pressure coil, right? So Vp is the voltage that is applied to the pressure coil, because you might be knowing that in energy meter there are two coils. One is considered as a pressure coil, and the second one is considered clearly as current coil, right? Current coil. So the idea is pressure coil will be carrying the voltage that is exactly equal to the load voltage. Current coil will be carrying the current that is actually to be flowing through the load here, correct? So then what is the answer here? So what is the idea here? So the idea is, even though if the current coil is carrying 0 ampere current, that means there is no current through the load. But if at all you have applied the more voltage at pressure coil, more voltage to the pressure coil, or else if there is some friction problem, or it's not because of the friction, because to reduce the friction we will do overcompensation. Because of that, what happens is, even though there is no load current here, even though when there is no load current or when there is no current flowing through the load, the disc will continuously rotate, very small rotation, very small speed, very little speed. That means it will slowly rotate in between the north pole and south pole. The disc slowly rotates. That slow rotation or the slow movement is actually called as a creeping. Clear? And in fact, the name itself very beautifully written like creeping, right? Now moving ahead to the next one, that is Maxwell bridge is used for the measurement of dash, having the quality factor in the range of dash. See, maybe you might be knowing that Maxwell bridge, that may be Maxwell inductance bridge or Maxwell capacitance bridge. Both of these two are basically used to measure the inductance of a coil, correct? Inductance of coil. This is a fundamental question, correct? Right? So there are two bridges majorly speaking. One is Maxwell capacitance bridge, second one is Maxwell inductance bridge, and both of these two bridges are used to measure the inductance of the coil. Whenever we are measuring the inductance of the coil, we will come to a question that whether the quality factor should be high or low. Clear? Quality factor is high or low. Correct? So the question is simple, right? So usually we will not use Maxwell bridge to measure the low quality factor coil, and we will not use to measure for the high quality factor coil, right? Usually we will try to use the Maxwell bridge only to measure the medium. See, M and M, it's very easy to understand, M and M. So Maxwell inductance bridge is used to measure the medium Q coil, right? So if you look at, first of all, straight away these two options are wrong, because we are going to measure the inductance as I was saying here, correct? When we are measuring the inductance, option B, option C are wrong. So either option A or option D should be correct. But you can see here the quality factor is very high. Usually this can be done by the Hayes bridge. Clear? So Hayes bridge and high quality factor, that is the way you can remember. So this is also not the option. What would be the correct option? Option D is the correct option here, and that would be the probable answer for 69th question. Moving ahead to the 70th question, and again this is a very simple question here. Calculate the resolution of 3-digit 0 to 1 digital voltmeter, correct? 0 to 1 digital voltmeter. So what is the resolution? Generally for the DVM, the resolution could be written as 1 divided by 10 power n. I am not going so deep here because the question is very simple, but generally you need to do more and more, okay? 1 divided by 10. So tell me, what is 1? So 1 is the full scale value here, that is the 0 to 1 volt is the range here. 1 divided by 10 to the power of number of full bits here, or number of full digits. So 3 actually denotes number of full digits here, clear? Right? So full digits here. So I hope you understood this, right? So when I say 1 divided by 10 power 3, obviously you can manage this to get the value of 0.001. What would be the correct answer here? Correct answer is option D. Such a simple question. Again and again I am saying that HPCL is very easy if you really prepare very well for the GATE examination. Clear? Thank you very much, Basha. So option D is the correct answer. Hope every one of you are following here. So some students are silently replying me whenever I ask, but you should interact with me to get more and more concepts here. Clear? So anyway, that's the idea of all the way measurements. And now coming to the beautiful and very important subject in the entire engineering domain, that is control system. Clear? So moving ahead with the statement of the first question in control system, please see and read the question and answer. So there are some students who are answering here, so please answer here. So what is the question? So let me read the statement of the question first of all. In a signal flow graph, dash is the gain along any path from the input to the output, not passing through any node more than one. See, this is the question. In fact, this is the last phrase is very important for this question. Basha, what would be the answer here? So simple. Suppose, look at that. We have something like this. 3 nodes we are having. Node 1, node 2, node 3 in the signal flow graph, for example. And for time being, let us say that the signal flow graph is given like this. It is 2. So this is 1 is the node, 2 is the node, 3 is the node. Correct? So 2 is the gain here, and again 4 is the gain here. Correct? Otherwise, let me take the gains here, for example, instead of this. Right? So let us take these things as G1 here as a gain and G2 as a gain here. Clear? Now you all can see, yes, very good, D, forward path gain, excellent, right? Now you can see, by chance, if I connect this to the loop here, right? So this is the feedback loop, I say, right? So let me call this as a H. Now what is the question? He is asking that in a very simple language, start from one node and reach to the final node, but don't touch anything, right? So that means if I start from this here, all the way I have to travel like this, right? I have to travel like this up to here, right? So that is called forward gain. So what is the forward gain here? So forward path gain, I could say forward path gain here in a simple language, that is going to be equal to the product of every possible gain in the forward path, right? So that is G1 and G2. Now you must answer this question simply, right? So if at all, if I go like this, so assume that I started like this and all the way I am moving like this, moving like this, moving like this, and if I come back again like this, then what will going to happen? I might touch the node 2 for 2 times. That means loop gain is not possible, closed loop gain is not possible, feedback gain is also not possible. In fact, all 3 options, first 3 options same almost, right? That's why option 4, that is the forward gain, is the correct answer. Basha, you really enjoyed this or not? Tell me. And Kanchan, every one of you. So did you really feel that HPCL is easy? If you seriously prepared for GATE, I should say that it is a cakewalk, right? These questions cannot stand like 1 mark question also in the GATE examination, correct? Everyone must answer to me, right? So Basha is so active and Kanchan is also very much active, right? So that's fine. So option D is the correct answer. Even if you don't know what is the right answer, but you can see A, B, C, 3 options looks like same. So the only option which is different out of 4 options is D, right? So that's about this. And I would like to remind you one important fact. In one of the very important event today, Abhinav Nagi Sir, the most expert in the Byjus team from the civil engineering department, he is going to handle a workshop that is step-by-step guidance from the beginner to the topper, GATE topper. Okay, the entire journey of the GATE topper, because many of you might be having the thought that yes, I want to become the GATE topper, right? If you are the person who is really want to become a GATE topper from the starting, it is going to be golden opportunity to you attend the live session, that is workshop, free workshop. Just you need to click and register and happily listen. Lot of information, motivation, guidance will be provided by Abhinav Nagi Sir today sharply at 8 p.m. Okay, don't miss the class. As I said, it is a free workshop and register for that. 8 p.m. you are going to have the live session. Clear? Right now, let us see the next question here. Which of the following system is an example of closed loop control system? Right? So first of all, let me remove this one, bread toaster. Why? Because if you switch on the bread, right? If you switch on the bread toaster, naturally 10 minutes or 15 minutes it will take. And if you switch on for 10 minutes, you will enter the time like 10 to 15 minutes. Wherever you are entering the time and the entire action is taken based on the time, that is completely called as a open loop control system. Because in bread toaster, what happens? We will enter the time like 10 minutes or 15 minutes. Even sometimes the bread may be toasted, but still it will wait up to 15 minutes to give the signal to you, correct? So that's why it is a completely not acceptable. It is not a open closed loop system. Same with the TV remote control, correct? We will give the input, but we will not take any input from the TV control, right? So the traffic light control system is also same. Have you ever seen, if in the signal, if it is showing like 20 seconds red, means even though if there is no vehicle on the road, it will be showing 20 only again and again, correct? Because it will not actually see the density of the or current in the road. That means it will not check how many people are there. It will blindly keep 20 seconds this signal, 20 seconds that signal, 20 seconds that signal, right? So that's the problem with the traffic signal, and that is also open loop control system. Of course, the only option which is left here is option C, that is voltage stabilizer. So what do you mean by voltage stabilizer? Anyone? Right? So maybe you might be answering correct, but I am asking a question that iska matlab kya hai? What does it mean? Voltage stabilizer means if there is any fluctuation in the voltage, that will be taken as a feedback and the regulation will be done so that the voltage, output voltage will be maintained at the same voltage. Best example is we will use the stabilizer for the fridge, air conditioners, as well as even sometimes the televisions also, right? So the advantage of stabilization is it's a closed loop system. It naturally detects what is the fluctuation in the voltage and it will try to control the voltage, the energy, such that it will not disturb the load. Clear? That's the advantage of that. Moving to the next question, right? So as per the force voltage analogy, mass, viscous and friction in mechanical translation system are analogous to dash and dash in the electrical system respectively. I want the answer from you. Now let me see how many of you can answer fatafat here, right? First of all, if you see the force versus mechanical displacement, right? So it is a famous equation that is, if you take mass damper spring system, we all can say it is the way how we will be writing m into d square x of t by dt plus c. C stands for damping coefficient here, so c into dx of t by dt. Some people write like c, some people write like d, b, anything is fine, right? So plus the spring coefficient is k into x of t, correct? So this is the way how the equation can be written. I hope that every one of you know this equation, right? So Basha and Kanchan, both of you should give the answer here. I am waiting for your reply here, okay? K into x of t. Any one of you? Right? Constant voltage. Okay, very good Kanchan. Now look at this question and answer. So this is the force versus displacement, okay, in mechanical system. Clear? So this is in the mechanical system, I can say. Mechanical system. Clear? But when we take electrical system, because the voltage is the usual notation in the electrical system. So let me take electrical system for time being. And if I take electrical system as an example, the intention is very clear. The applied voltage in RLC circuit, let me consider this as the R and L and C. So if you have resistor, inductor and capacitor, what should I say here? Option D. Basha is saying option D. Let us see what will be the correct answer, right? So resistor is there, inductor is there and capacitor is there all the way, right? Suppose if I apply some voltage here, so let us consider that there is some voltage that is applied here. So let me call that as a VI of t, correct? And we have resistor here, and we have inductor here and capacitor here, and we all know that the current will be driven like this. So let us consider that this is the current here, I of t. Same current will be flowing here, and I can say the same current is flowing here also, correct? So as the current flowing in each and every element is same in the closed loop, I can say I of t is the current that is flowing in the circuit, or else I can say I of t is the current that is flowing in the capacitor IC of t, which eventually will be called as C into dVc of t by dt here. So simple to understand, correct? C into dVc of t by dt, which is called as a current through the capacitor. Clear? Now come to this level here. So the applied voltage here should be equal to what? The voltage across the resistor, that is VR of t, correct? Plus the voltage across the inductor, that is VL of t, correct? Plus the voltage across the capacitor, that is VC of t. Simple. Now if you go ahead one step here, right? So any one of you can identify here what is VR of t. VR of t is it can be written as R into I of t, plus VL of t can be written as L into d I of t by dt here, correct? And VC of t, don't disturb that, let us keep VC of t as VC of t itself, because we want the output in terms of voltage here. Can anybody say here what would be the final answer here? I of t, as I said, we can replace that with the C into dVc of t by dt. So therefore it will going to become like now RC into RC into dVc of t by dt here, right, dVc of t by dt plus L into right, so di of t by dt, right, so di of t by dt, that means if you differentiate this, it will going to become like L into C into d square Vc of t by dt square here, right. So let me take, you know, other color here. So I hope you got the fundamental points very clearly here, because these things are seems to be very, very simple, right. So now moving ahead, we got to know up to here. So what else is left here? We left with the Vc of t, correct. So now you can see left side we have Vi of t. Is it looking like a standard differential equation first of all here? Yes, of course it is a standard differential equation. If it is a standard differential equation, you can see the order of the differential is 2 here, and for mass also order is 2 here, correct. So usually this M stands for where? From where it came? This M came from all the way, right? So the mass, right? So the inductor, correct. So this M, this higher order differential equation came from inductance. So L will be considered as your mass here, clear? That is the first thing. And second thing, you can see the coefficient, friction coefficient, they are asking viscous friction, that is C, which is nothing but a multiplier of first order derivative factor, correct. So first order derivative factor we have RC, but where it came? It came from the resistor. So that means this is the value here, right. So the answer is mass represents the inductance and viscous coefficient or viscous friction represents the resistance here, clear. Option D is the correct answer. So clear every one of you. So please tell me, Basha and Kanchan, is the explanation is clear? Are you really feeling this HPCL exam is easy? If you are feeling exam is very easy, I really appreciate you. So please tell me in the comment section whether you are feeling it easy or not, right. So I am not explaining this very simple way, because the questions itself they are very simple, okay. Right, look at the next question. For the second order system, having its transfer function as h of s is equal to 25 this by this, what is the damping factor? Again, this is also very easy, right. For the second order system, we know that the general transfer function of the second order system could be written as omega n square divided by s square plus 2 zeta omega n into s plus omega n square, isn't it? Now if you compare this with this function, that is 25 divided by what is there here, so s square plus 8s plus 25 here, this is what we are having, isn't it, right. So yes, Kanchan, thank you very much, right. So now look at that, beauty of this is, now compare this here to here, right. So omega n square could be written as a 25 here, so therefore omega n must be written as equal to under root of 25, which could be written as, of course, the mathematically it may be like, you know, plus or minus 5 radian per second, but we know that we will be only applying the frequency in the positive zone. So the answer is 5 radian per second, that is omega n. But if you look at 2 zeta omega n, that means compare this value with this value, that means coefficient of s in the denominator, then what it will become? 2 zeta omega n, it will going to become 8 here, and then zeta could be written as equal to 8 divided by 2 times of omega n, that is equal to 8 divided by, what should I say, 2 into 5. So obviously this will be equal to 0.8, correct. So zeta value is 0.8. So what would be the correct answer? Option D, right. You people are so fast compared to me, right. So anyway, good, great, right, 0.8 is the answer, right. Now moving ahead to the next one. Now let me see how many of you can answer here, Kanchan and Basha and other people. So tell me here, Pallavi, what would be the correct answer here? The breakaway points of the root loci of a polynomial equation can occur. So it was already known that on real axis breakaway point can occur, right. Suppose if I have a function, let us say loop gain is something like this, g of s into h of s is equal to 1 divided by s into s plus 4. Look at that. Otherwise, I will tell you in a simple way. Just let us consider in this way. So any one of you, can you answer here? Any one of you, can you see what would be the correct answer here? So let me see how many of you will answer. Suppose if you take S plane like this, this is sigma, you know, and this is minus sigma here, and you all know that this is j omega and this is minus j omega here, correct? So as I was saying, first thing that this is the S plane, right? Suppose if I say there is a pole here and there is a pole here, let me say this is 0 and this is minus 4, and there might be a pole here and there might be a pole here. So let's consider that this is minus 2 plus 2j here, and this is minus 2 minus 2j. So how many poles are there altogether? 4 poles are there. Can you see what would be the way how the root locus looks like here? Kanchan, wrong answer. Not only on the real axis. Now I will tell you the most beautiful point, so please see. If you are having the root locus like this, right, the very first thing you can understand that, right, so you will be having the asymptotes like 45, 90, 135 and 225, right? So the asymptotes all the way it will come like this. Maybe the breakaway point might come here at 2 here, so then it will be somewhere like this, correct? So you can see this is considered as one asymptote, second asymptote, third asymptote and fourth asymptote. If you want, you can try with these 4 poles here, right? So this is a breakaway point, I mean this is a centroid, I can say centroid. Then what happens here is from here to here, right? So let me say obviously from here to here this will come like this, right, and this will going to come like this. Both will going to meet together at this point here, correct? So they will going to meet at this point. Interesting fact is after meeting at this point, right, so then naturally the breakaway point it will go in the upward direction, and from here this pole will come in the downward direction, come downward direction, come downward direction, correct? So then you can see there is a meeting point once again here, right? So one breakaway point came here, right? So now the lower asymptote or the lower root loci it will come all the way like this here, but you must also understand that one more branch from this complex pole it will come like this, correct? It will come like this, right? So this is the way how it will meet, right? Again there is a meeting point here. So there are 3 meeting points. So I can say this is a first meeting point, second meeting point and third meeting point. So at first meeting point the root locus branches which are on the real axis they will meet, and then from there it will go into breakaway, right? One is in the upward direction, one is in the downward direction, and then another root locus branch which is coming from the complex pole that will come and meet at this point here, right? Again after that it has to break away, correct? So that means now if you look at the beautiful point of this, even in the complex pole also it will going to be breakaway, right? So I say one second here, right? So again in the complex plane it will all the way go like this, right? So this is the way it will follow the asymptotes here, and same thing will happen here also. It is a breakaway point here, and again this will all the way it will come out like this, and it will also go in this way, clear? So what does it mean? Because we all know that fundamentally that a breakaway point can occur on the real axis, we all know that, and can occur not only on the real axis, even at the complex plane. So there are 3 breakaway points. This is the breakaway point 1, BAP 1, and this is the breakaway point 2, breakaway point 2 here, and this is the breakaway point 3, clear? So let me say breakaway point 3. What does it mean? It means that though you have studied that the breakaway point can occur only on the real axis, that is only partial conclusion. Basically breakaway point can occur anywhere in the S-plane, right? So you can see it's a very simple thing that breakaway point can occur anywhere in the S-plane here, right? So that's why it was asked that in the option D it was mentioned that breakaway point can occur anywhere in the complex plane, means anywhere in the S-plane. So both are correct here. So complex plane means I can say instead of complex plane I can say S-plane, correct? So most of the students will go for option B, but that is wrong answer. Option D is the correct answer, clear? So right, moving ahead to the point of stability that is mapped into the Nicholas plot. So whether it is a Nicholas chart or whether it is a Bode plot or polar plot or Nyquist plot, whatever it may be, you must understand that they are frequency response plots, right? So in frequency response plot, this basically it indicates that G of S into, one second, so it can be written as G of S into H of S. It's a complex function, and in the complex function it is mapped as -1 comma J0. How can I write this one? It means that G of S into H of S should be written now as -1, clear, plus J into 0. True, what would be the modulus of this? So because we will replace S is equal to J omega here, so then I can say G of J omega into H of J omega, right? It must be written as -1 plus J0, correct? So this is very important, right? So if you write like this, then quickly from here we can say modulus of this, that is if you find the magnitude of this, modulus of G of J omega into H of J omega, it would be equal to what? So we have a real part and we have an imaginary part here. So therefore I should write down under root of real part square, that is -1 square plus imaginary part square 0 square, all put together this is equal to 1, right? So if you take in dB, so that means magnitude only, but if I collect in dB here, so then what will going to happen here? If I take in dB, then I should take that 20 logarithmic of whatever the value we have here. So the value is 1 here. So if I put 1 here, 20 log of 1, that will become like 0 dB here. Clear? So that is your magnitude. What about the phase here? So the phase of this function, if you see, that is phase of g of j omega into h of j omega here. So the idea is so simple here, because we can see imaginary part is 0, real part is -1. What does it mean? In polar plane, -1 comma 0 means this is the point where it lies, correct? So this point is from here to here, correct? So it will be at 180 degrees in clockwise, and if you go from this side, then obviously it is in -180 degrees. So basically this must be written as a plus or minus 180 degree. But as I was repeatedly saying in the vision classes and other online classes also, that we are going to use a physically realizable system. Physically realizable system is the order of the denominator must be at least equal to the, the order of the denominator must be equal to the order of the numerator polynomial in the transfer function, or the order of the polynomial of the denominator of the transfer function must be more than the order of the numerator polynomial in the transfer function, correct? So in both the cases, you must understand that. So for practically realizable system, we will be having only the negative phase, clear? So -180 degrees. What does it mean? 0 dB is related to gain, -180 degrees is actually related to what? Phase. So option B is the correct answer for this question. As I was saying, this is also a very simple question. I feel that every one of you could already answer this. Again, this 0 dB -180 degrees, it is not only a plot to the Nicholas chart. Even the same basics of critical point of stability we will use in gain margin, phase margin, followed to that polar plot, Nyquist plot, everywhere we will use the same thing, correct? So this is all about the questions from the HPCL 2021 paper. Hope you guys really enjoyed with this, because I have seen some of the good response from the students. Again, I am saying that the HPCL questions are not difficult. Technical questions are not difficult, right? But the bad thing, I should say, in fact, the toughest job is the GATE students. You have to, maybe you may be able to answer very easily the HPCL question, but the aptitude part is the most challenging one. Anyway, we have a special sessions taken by Rakesh Sir on the aptitude, so you people can connect to that and attend. And now let me come to the last part of the session, that is homework questions. Okay, so as we have all discussed that, we have solved almost many questions. Now it's the time for you. You should take up the challenge and solve the questions from your side. So I'll give some questions, like 5 to 10 questions in between, somewhere around that. And again, I'm saying that today sharply at 8 p.m. we have a session, workshop, that is how to go from step by step to the gate, from the beginner stage to the gate topper. Again, I'm saying that would be a wonderful session, and it will be a useful session, and it will be taken by Abhinav Gupta sir. So, and most importantly, today sharply at 8 p.m. the workshop is going to start. So please go and register first. Anyway, take up the homework question. So this is the first question of the homework, and you can see, every one of you, please pause the video and take the snapshot of this question and solve by yourself, so that your practice will be good here. Clear? So this looks like a very difficult question or lengthy question, but once you go deeply into the topic, this question seems to be very, very easy. In fact, I should say most easy. Clear? So this is another question, right? So another 3-4 questions are there. This question is from the measurement, and it is a 2-watt meter method, and those students who have already attended my classes, it is a cakewalk to them, right? And other students, at least try to go through the recorded lectures which are available in the BEP app, and then you will feel that these questions are so simple. Clear? So again, these questions are from the core electrical part, right? And most importantly, this would be the last question here, right? So everyone, see this question, such a simple question this is, right? In a magnetic circuit, the ratio between flux and MMF is dash, right? In electrical circuit, we all know that if you apply voltage, you will be getting the current and resistance. But in magnetic circuit, what should I say? MMF is the driving force here, and the flux is the result, and that should be multiplied by the reluctance here, correct? So this is considered as a reluctance, right? So now what they are asking, so here if you see, according to this, the ratio of the flux to MMF is dash. Flux to MMF means what it will become? It will become like 1 by, right? So 1 by reluctance here. So that is equal to flux by MMF here, correct? So 1 by reluctance is actually called as what? Look at the options here, right? So first of all, definitely not the resistance, and the reactance also not the correct answer. And we have seen that it is not reluctance, it is 1 by reluctance, means it is inverse of reluctance, which is called as a permeance. Clear? So option D is the correct answer. So this is also a very simple question, right? So that's why I'm saying that the question seems to be very easy. The only thing what you must remember is practice. And second is you should be good at aptitude compared to the technical part, because technical part anyway you will be able to answer. Clear? So I have given the homework questions also. Hope this session is really useful to every one of you who are being consistently in the live session from the starting of the session. I should really appreciate your patience and your energy. Hope everyone will do very good in the final examination of the HPCL. I wish for everyone, I wish all the best. Do well in the final examination. And again, don't forget to register right immediately to Abhinav sir, because he is going to take a session and workshop how to go step by step guidance from the beginner to the gate topper. Don't miss this session sharply at 8 p.m. today. Clear? So well, that's the end of the discussion. Hope you really enjoyed this session. And once again, if any PSU notification comes, we will definitely come with these great sessions. So your interaction will give energy to us, and our energy will directly motivate you and directly provide the guidance. So let's enjoy the journey together. Thank you very much once again. Thank you very much.